And now, ladies and gentlemen, the hardest working MC in the cosmos, Vincent Coulahan.
Hey, good morning, everybody. I'll say good morning and good afternoon because I'm sure it's afternoon somewhere in our streaming area. But thank you all for being here today. We have an extraordinary program for NEAF today for all of us. Just a big shout out to all of you for being here. And our first speaker to kick off this program today is truly extraordinary. A planetary scientist, program executive. I'll put all that aside for a second. And the reason that I would like to just put this, he has taken us on a journey across our solar system where nobody has taken us before and have provided us an opportunity to learn. And all of us, just talking to some of you out in the audience, to inspire to a true leader. And this person is a leader in his field. It is with great pleasure that I have to introduce to us here at NEAF 2019, Dr. Alan Stern. Thank you.
Thank you. Hey. I need a camera. There she is, too. Should be taking a picture of you. Actually, it's, I remember this stage from 2016 when I was here before. And the way that the lights work is kind of a fog. I can see only the first 3 rows, and then after that, maybe no one else is here. Anyway, it's great to be back at NEAF, and it's great to have a chance to tell you about the latest chapter in the story of New Horizons. I'll get right into it. I've been very fortunate in my career to now have been on the science teams of 29 space missions, from suborbital sounding rockets to space shuttle missions to planetary missions and more. But of all of those missions, New Horizons is absolutely my favorite. And how could it not be? You know, for planetary scientists, space exploration is our strongest tool because we have to go close to these places to make the high-resolution measurements to really understand them. And the very best space missions to be on for a planetary scientist is to be on a first mission to a new planet or first mission to a new class of object. You know, sometimes people say that's like a chance to scientifically take candy from a baby. Right? And in the 60s and 70s and 80s, those first missions to the planets, starting with Mariner 2 to Venus and Mariner 4 to Mars, and all the way stretched across through the late 80s with Voyager, they were happening all the time. We went to 8 planets in 27 years, from 1962 to 1989. 1989 is the year I finished graduate school, and there were no more first missions. And then a generation later, New Horizons got to go explore the Pluto system and do something like those hallowed missions, like Voyager and the Mariners. And so, because it's really the last train to Clarksville, the only chance for us to get to do something like that, I think for all of us that are involved, there's just nothing that can replace it in terms of an experience. And of course, it all worked out. But the other reason that New Horizons is my favorite is because of the men and women who formed the New Horizons team. You might not know this, but over the almost 20 years since we started the project in December of 2000, over 2,500 Americans have worked on New Horizons. Mostly during the build stage. As a flight team, we're much smaller, about 50 belly buttons, and around the flybys, a couple hundred. But it's a big team, and I know that one of our team members is here, Steve Kennard of the Johns Hopkins Applied Physics Lab. There he is. Give him a round. Anytime you see high-resolution images made by New Horizons, our highest resolution camera is called Lori, and he's been the project engineer on that since its very beginning. Thank you again, Steve. Thanks for coming to the talk. Okay, please, give him a round. So this really is an epic journey and a historic journey that New Horizons embarked on. I'm going to give you some background on the project. I know many of you probably know that background because you may have seen me here in 2016, for example. But then I'm going to, after we walk through how the project came to be, what the spacecraft is all about, what the instrument payload is all about, I'm going to tell you just a little bit about the flight across the solar system and our exploration of Pluto. But then we're going to hit the next phase, our first extended mission and another record-breaking flyby more than 1 billion miles beyond Pluto in the Kuiper Belt with Ultima Thule. So let's get started. First of all, it was a very long road to get the exploration of Pluto funded. There were a lot of failed attempts. You can see 6 of them there. There were others too. The first 5 never got off the drawing board. From 1989 until 2001, it was study after study after study, and for one reason or another, none of them worked out. They blew up on cost. They had technical problems. They had management problems. In some cases, there were political battles. In one case, we were almost ready to get a new start to send a spacecraft to Pluto in the early 90s, and a spacecraft about to pull into Mars orbit, a NASA spacecraft, blew up, and the money was taken to replace that, and it was almost another 10 years. So for those of us, and it's not me, it was a substantial part of the planetary science community who really believed that this next phase of exploration could be so important and so rewarding. It was a long slog. It took a lot of tenacity, a lot of persistence, but it turned out to be all worth it. We have to start this video, so Oren could do that. This is a view looking down on the orbits of the outermost planets, and the dots that you see appearing are discoveries made in the early, mid, and late 1990s of this third zone of the solar system called the Kuiper Belt. The Gerard Kuiper, born in 1905 and one of the leading planetary scientists of the mid-20th century, had postulated. But it took until the 1990s for technology to be good enough to be able to spot objects out there, except for Pluto. And this is Pluto's context. All those small dots are what we call small KBOs, Kuiper Belt objects. The bigger ones are dwarf planets, like Pluto, that turn out to outnumber the giant planets and the terrestrial planets combined. And together, this whole assemblage forms this ring, or belt, very puffy belt, beyond the orbit of Neptune. So we have the inner planet zone, the giant planet zone, and the Kuiper Belt zone. And this third zone of the solar system had never been explored. Now, it's true that some spacecraft had been there. The Pioneers and the Voyagers flew through that region. 3 of the 4 spacecraft flew through the region before they knew there was a Kuiper Belt, blissfully unaware. The last one got there just about the time the Kuiper Belt was discovered, but by then it wasn't capable of making flybys of anything there. So New Horizons was purpose-built to do this. And after all those years of struggle in the Washington political beltway maze, where it felt like Lucy in the football over and over again for a dozen years, finally, through what we call the decadal survey process that sorts out priorities and comes to consensus, the exploration of Pluto in the Kuiper Belt was ranked at the very top of the queue for funding. And Congress and the administration listened to that, and as a result, we were able to really have a new start and go and do this mission. There was one more step, and that was that NASA conducted a competition and let any team that wanted to form come to them with proposals for how to do it, and how to do it on budget and on cost, and to accomplish a long list of specific scientific objectives and show that you could do it reliably. And our team, called New Horizons, consisting of my institution, the Southwest Research Institute, and our partners, the Johns Hopkins Applied Physics Lab, along with many other contractors and scientists from all around the country at universities, government labs, at NASA, wrote a proposal about that thick, and fortunately for us, our proposal was deemed better than the other guys, and in November of 2001, we were selected to be the team to explore Pluto in the Kuiper Belt. And I have to tell you, when I got word that we had won, and And I started to hear congratulations from a lot of colleagues, but a lot of them wrote emails and said to me in person things like, well, congratulations, you won, but you probably also lost because the amount of money they're giving you is only 20% of what Voyager had. And if you don't launch by January of 2006, you won't get the Jupiter gravity assist. So between one of those two things or getting nuclear launch approval, one of those is going to catch you, and I just don't believe this will ever make it into space. So you won, but you lost. Wasn't that great? So we took that as sort of a personal challenge. You know, I remembered this story from 1961. It's apocryphal in space exploration, that the day that John Kennedy, the president, announced that we're going to send Americans to the moon before the decade is out, the head of NASA at that time, Jim Webb, called his senior staff together that afternoon and said, well, boys, we got what we asked for. Now what do we do? That's a little how we felt. But thanks to that amazing team of people who literally worked for 4 years and 2 months without a break, lots of nights and weekends, 52 weeks a year, we managed to get a spacecraft designed, built, tested, and down to the launch pad in record time. Typical outer planet mission takes 8 to 12 years to develop. We had 4 years and 2 months. And we had to break the mold on cost. So we designed this spacecraft. For reference, the dish antenna is only about this big. Now, how many of you have been to the National Air and Space Museum? Raise your hand. Okay, at least in the front few rows, a lot of you. There's a place there called the Hall of Exploration. And Voyager's hanging from the ceiling. And next to it, as of a few years ago, in 2015, New Horizons is hanging next to it. And Voyager is enormous compared to New Horizons. I mean, I call it the houseboat and the hamster. But you know, just like the PC revolution from the 70s when Voyager was built to the 2000s when New Horizons was built, computers kept shrinking and shrinking and shrinking in size and shrinking in cost, but getting more and more powerful, which seems impossible. But that's what happened. And it's precisely what happened with New Horizons as well. We're much smaller and much less expensive, but the spacecraft is actually much more powerful in terms of computing capability, in terms of onboard storage, in terms of navigation capability, and the technology that goes into the 7 scientific instruments on board is a whole generation ahead of Voyager. So let me tell you about the instruments that we have on board and what they each do. I'll just walk you around the circle, and we're going to start with LORRI that Steve works on. LORRI stands for the Long Range Reconnaissance Imager. For this crowd, you'll understand what I mean when I say it's basically a high-tech C8 with a 1024 by 1024 CCD chip at the back end. Just very simple in that regard. It's not all singing, all dancing like some of the other instruments, but it's our long focal length camera. So it lets us start on any flyby much farther out than our other cameras because of that resolution capability. And when we get close, it gives us higher magnification and therefore higher resolution imagery. So that's LORRI, and LORRI was built at the Applied Physics Lab. Just moving to the right, you see the student dust counter. That's a dust impact detector that can determine not only when dust impacts occur on the spacecraft, but the seismic magnitude of the impact, from which we can put together what we call a size frequency distribution of the debris across our solar system, which we've been tracing out now almost to 50 astronomical units. The previous record for any dust counter experiment were on the Pioneers back in the 1970s, and they only worked until they gave up the ghost at 17 astronomical units. So inside of Uranus's orbit, we're much further than twice that far out now, developing new results. And this is the first instrument ever built by students for a planetary science mission. So we're very proud of that. We kind of broke the mold. A lot of missions now do that. Ralph is our most complex instrument on the spacecraft. It was built by Ball Aerospace in Boulder, Colorado. It's about this big, and it costs as much as a luxury hotel. It has 8 cameras on board, both panchromatic and color, and it has an infrared mapping spectrometer that can plaster 64,000 pixels onto a target at once, and we get a spectrum at every location. So we can blanket a planet or a satellite or a Kuiper Belt object and get its composition at every location. And the miniaturization that went into this is unbelievable. Then there's ALICE. ALICE is an ultraviolet mapping spectrometer whose job is to determine the density and composition of atmospheres of things we fly by. It was built at my place, the Southwest Research Institute in San Antonio. REX is our radio science experiment. It's a part of the telecommunication system on the spacecraft. And at Pluto, its primary job was to develop a temperature pressure profile down through Pluto's atmosphere all the way to the base, which it did perfectly. But it can also measure temperatures on the surface of things it goes by. And in flight, we developed a technique to actually make it a radar detector and to send powerful 80 kilowatt radar beams up from the Earth with NASA's Deep Space Network and measure the radar reflectivity of our targets as another physical probe of what their surface properties are. Then Pepsi and SWAP round out the payload. Those are two charged particle spectrometers. Pepsi works at megavolt, mega electron volt ranges and is primarily measuring what are called pickup ions that are they're species that get ionized and then picked up on the magnetic fields out in the solar heliosphere. And as they wash over the spacecraft, it ingests some of those and can measure their composition and density, telling us about what's coming off the surface or an atmosphere of a flyby target. And then SWAP's main job in this mission was to measure the escape rate of Pluto's atmosphere. But it's also used to study the heliosphere and to look for interactions with other objects we fly by, like Ultima Thule, our flyby target. This is the spacecraft down at the Cape in December of 2005, shortly before we put it on the rocket. Now, I like this picture for a lot of reasons. One is the people around it give you a sense of the scale. This spacecraft is about the size of a baby grand piano. It weighs, or did weigh, when we launched it, about 1,000 pounds. That includes the fuel that's inside in the fuel tank. And we don't use that fuel to propel us very often. That was done by the rocket and by our Jupiter Gravity Assist. But we use it to point the spacecraft and to make course corrections, with one exception I'll tell you about later. Inside that spacecraft are all the flight systems you need for a journey that's already lasted now over 13 years. So onboard guidance and control, propulsion, data storage, command and data handling, thermal control, star trackers, gyros, et cetera, et cetera. And this spacecraft, like most planetary spacecraft, is fully redundant. Not the instruments, but all of the spacecraft subsystems are either internally redundant or we have two boxes for everything. The dish antenna you see on top, as I said, it's about 6 feet across. The device on the left that's black, I'll point at it there, is a nuclear power generator. It's a plutonium-filled nuclear battery that converts the heat of radioactive decay into DC electricity to run all the systems and the experiments on the spacecraft. And at launch, it was giving us 250 watts, but because plutonium has a half-life, every year it produces about 3 less watts. As of last week, we're at 189.1. But as I'll tell you at the end of this presentation, we have enough power on board that nuclear battery to continue running the spacecraft probably for close to 20 years. Okay, this is our ride. It's an Atlas V. At the time that we bought this rocket, it was built by Lockheed Martin, which later formed a partnership with Boeing and called the United Launch Alliance, who builds and produces this rocket. They have now flown many dozens of them, all of them successfully. We were tail number 10, so we were very early in the production stage. And I think I told this story, so forgive me if you were here before in 2016, but when I was a little boy, I really wanted to grow up and be in space exploration, and I saved all my allowance and washed cars and mowed lawns and even did babysitting to raise money to buy bigger and bigger Estes model rockets. So you have no idea how much fun it was to order one of these. And we tricked it out with everything in the book. No expense was spared because this is such an enormous journey of 3 billion miles. You know, it took Voyager 12 years to reach Neptune. We were going even further, and we wanted to do it more quickly, in part because we were concerned that as Pluto was drawing away from the sun, its atmosphere would cool off and eventually snow out onto the surface. We wanted to make sure we got there while there was still an atmosphere to study. So this rocket, it's hard to tell from that picture, it's the size of a respectably tall Manhattan skyscraper. It's 226 feet tall. It's got 5 solid rocket motors, each 70 feet tall, in addition to the main stage. And then it's got the Centaur second stage, which is liquid hydrogen, liquid oxygen, the most powerful combination of fuel and oxidizer that we have. And for New Horizons, that wasn't enough, so we topped it with a solid rocket motor, what's called a Star 48, to be our third stage. And then you see the payload bay, the nose cone of the rocket. It's 70 feet tall. And I remember getting a chance to go in the payload bay when New Horizons was in it. And it was like, we're basically launching this monster empty, right? There's little New Horizons, 70 feet of payload bay, right? And the result was a ferocious combination because we were so light. At the end of the third stage, propulsion, as we were leaving Earth orbit, the spacecraft was pulling 14 Gs. No exaggeration, 14 Gs, and became the fastest spacecraft ever launched. Let me try for another show of hands. How many of you here remember Apollo missions that took 3 days to get to the moon? Right, 25,000 mile an hour burnout speed, 3 days to reach the moon. New Horizons did that trip in 9 hours. Yeah. You could literally, we launched at 2 in the afternoon in Florida on Thursday the 19th of January, 2006. We launched at 2 in the afternoon, and literally there was film at 11 that we were past the moon. Okay, and there was our launch. I did not bring a video of the launch, but it was one amazing day. And for everybody that worked on the project, you know when you go to your launch that this is going to be a memorable day, no matter how it turns out. You are not going to forget this. And it was memorable, and every part of the launch vehicle and the launch sequence worked just like textbook. In fact, because the launch vehicle delivered us so much more precisely on course than their actual specification, we were able to pocket a lot of fuel that's made this Kuiper Belt mission much more robust and is giving us a chance to maybe even do another flyby I'll tell you about later. Okay, so here's a cartoon that shows the route of flight across the solar system. We launched in January of 2006. 1 year and 1 month later, we were 500 million miles away at Jupiter for that gravity assist in February of 2007. And just to put that for scale, when the Galileo Jupiter orbiter went to Jupiter, it took 6.5 years. When Cassini did it, it was faster, 4.5 years. New Horizons, 1.1 years to Jupiter. And we used Jupiter as a flight test because it's the only thing we passed along the way. And we used it to target the flyby of Pluto with that gravity assist. It added about 5,000 miles an hour to our speed, and it shaved almost 4 years off the journey. Had we not had Jupiter, if we would have missed our little launch window and had to fly direct, do you know when the arrival date of that spacecraft would be? 4 months from now, on the 23rd of August, 2019. But thanks to the Jupiter gravity assist, we arrived in the summer of 2015, as it says there, and then off into this third zone of the solar system called the Kuiper Belt. So I know some of you have seen this picture before. It's the best picture of Pluto ever taken before New Horizons. Many scientific papers were written about this. But it really pays to go up close, and it really pays to have a spectacular instrument payload. And so this is the result. This is what New Horizons saw when we finally got to the 9th planet. What an amazing place this turned out to be. Complete scientific wonderland. And I, to this day, and my colleagues on the science team, we hear this all the time from professional planetary scientists around the world, that it just knocked people's socks off scientifically. glaciers the size of the state of Texas and Oklahoma combined, avalanches, giant ice volcanoes the scale of Mauna Loa. We made the front page of the New York Times, your hometown paper. I was not surprised. But what was surprising was how it turned other people on, and the enthusiasm, the thousands of people that came to be at the flyby. By the way, if you look at the back, there's a little countdown clock, and it says here, 4 seconds to fly by. Right there. This was in the moment. And then, of course, it was everywhere in the news, right? From the Google Doodle to countless magazines, hundreds and hundreds of newspaper covers, front page above the fold, and many other ways. And, engaging people about science and technology and enthusing young people to go into STEM careers is a very important part of what we do. And this mission was so seismic in its public interaction that NASA literally hadn't seen numbers like that since Apollo. And I think a lot of the reason, no doubt some of it was because we worked hard, but other missions work hard too to engage. And some of it was that Pluto turned out to be so spectacular. But I think what really made the difference was this was back to first time, who knows what's going to happen, what's it going to be like. We're going to a brand new kind of planet, and we're going to a place we've never been before, a vast scale. And that trifecta just put it through the roof. And then, as I said, Pluto performed, and the science that's come out of this is just incredible. And we have been publishing and publishing and publishing scientific results and been on the cover of Science and Nature and many dozens, in fact, now almost 100 scientific refereed papers out where we've discovered just the most amazing things. Pluto is almost certainly an ocean world with a vast ocean in its interior. It is the first binary planet that we've ever visited. That's its large moon, Charon. Not to scale the way this montage is put together. Charon's about the size, the width of the state of Texas. And Pluto is just about the width of the continental United States. And everywhere we looked, from the geology to the atmosphere to the interior to the satellites, everywhere, this is one tough nut to crack. Much more complicated than we thought. Some of my friends on the geology and geophysics team call Pluto the new Mars, or the other red planet. And we know that we need an orbiter to really figure this out. It's that complicated. One fast flyby revolutionized our knowledge, but it's not good enough. I can answer questions about that, but I'm not going to talk about it. But I like this. The solar system saved the best for last. What an amazing place this turned out to be. And what an amazing journey it was for all of us who worked so long against the clock to build it in record time, to build it at record low budget, and then to fly it. It sounds like science fiction, but it's not. To fly it across the solar system. And I remember when we first launched, and the project shrank from being a couple thousand people down to just a few dozen. And first I was a little depressed, to be honest. It's like, where'd everybody go? Well, we didn't need the engineers and the technicians for the most part. A lot of them were on call, but we didn't need huge staff to be building and testing and designing. And it was a flight control team and a science team and a few people to run it, and a small engineering team. And I realized one time we were all in a room together back in 2006, shortly after launch. I looked around, there's like 40 people in the room and maybe 10 on the phone, and I realized we're the flight crew. We're going to fly this thing all the way across the solar system, and we're going to be like a family by the time this is over. We're going to know each other so well, and that's exactly what happened. Now, this whole story, this is unabashed material. Put in a plug for your book. David Grinspoon and I published a book last year called Chasing New Horizons, which tells this whole story, which I've abbreviated. It goes right up through the findings of the Pluto flyby. It tells the whole political story of how it came to happen, the science story, some of the engineering breakthroughs that it took, and then the whole story, not just of how we flew it across the solar system, but how we planned the under-the-hood details of how you plan a flyby that's got to work because there's no backup. So if you have any interest in the story of New Horizons, this is a book I can recommend. By the way, I call it my 100 lost weekends because it took 2 years to write and rewrite and rewrite and rewrite until it got good enough that our publisher would accept it. But it won't take you 100 weekends to read it. In fact, when we first turned it in, it was about 500 pages long, and our publisher at Macmillan said, "It's a really good story. It's too long. No one will read it." And he said, "I'm going to hire a script doctor to come in and cut it." And we said, "Is that going to work?" And he said, "Oh, yeah, it works. We do it all the time." So 3 weeks later, he gives us back what I thought was kind of a butchered Chasing New Horizons. And it was so bad. I mean, that I remember being on the phone with this nameless script doctor who said, "There's no reason to bring up Clyde Tombaugh in this story, so I've cut him completely out." This is a story about the 2000s, not the 1930s. So David and I said, "No go. You can cancel our contract." They said, "We don't want to cancel the contract, but we also have a schedule to meet. You have 3 weeks to rewrite your book." And we did it. It was a bit of a horse race. We got it done. The book's a little under 300 pages. So let me go on, though. This is what I came here to talk to you about, is the extended, or what I like to call the first extended mission of New Horizons. And the way that it works in NASA is that when a mission finishes its primary objectives, if the spacecraft's healthy and there's good science to still do, and the price is right, then NASA will fund you for an extended mission. And some missions get extended over and over and over. Voyager's a good example, but many of the Mars missions, you just read about the Spirit and Opportunity project that was supposed to last 90 days that went for 15 years through a whole series of extended missions. So right after Pluto flyby, we proposed to do this Kuiper Belt mission, which the Decadal Survey back in the early 2000s had said is fundamentally part of doing this. And so we had a strong foundation. Spacecraft is healthy and full of fuel. And we had gone out with the Hubble Space Telescope and searched and found several possible targets that we could get to within our fuel supply. And then in August of 2015, just a month after the Pluto flyby, we went to Jim Green, who was on this stage yesterday. How many of you saw Jim here? Yeah, he was director of planetary exploration. And we told him why this particular one that we picked out, 2014 MU69, should be our target. And Jim agreed. He's the person that has to sign off on it. And then in October of 2015, we directed the spacecraft through some engine firings off the post-Pluto course towards an intercept with this object, 2014 MU69, which we later nicknamed Ultima Thule from the Latin. It means beyond the farthest frontiers. It came out of a naming contest on the web. So here's an interesting story. Is Jim here? Too bad. Maybe he's going to see this on video or whatever. But the NASA proposals, the extended mission proposals, weren't due until the 1st of April 2016. But it was very important to me to get on course for this target as early as possible. And so we went and told Jim, look, we want to get on course as soon as we can, because the earlier you fire the engines, the less fuel it takes to deviate for the intercept, and the more fuel we can pocket for possible future missions. And Jim liked that story, and it was true, and approved it. But of course, the other reason that we wanted to fire the engines and get on course is, with a healthy spacecraft, a decadal survey, and already on course for intercept, what are the odds they're not going to accept your proposal? They're just going to turn it off, and it's going to make the flyby, but it's not going to do anything. So there. Hi, Jim. Okay. So our primary objectives. Now, I have to tell you, I'm going to talk to you about the flyby of Ultima Thule. But our spacecraft is actually being used as an observatory in the Kuiper Belt. That C8, the LORRI camera in particular, is capable of observing dozens of other Kuiper Belt objects, and we do it all the time. And we have capabilities by being local in the Kuiper Belt to do everything from what are called phase curve studies to light curves to searching for satellites that you cannot do from the Earth or from the Hubble or anywhere else. So we're developing data on other dwarf planets besides Pluto and on many small Kuiper Belt objects to go with the close-ups of Ultima Thule. And we use our onboard plasma and dust instruments to explore the heliosphere In fact, currently we're the only spacecraft in the distant heliosphere because the two Voyagers have now exited into interstellar space. So we're the only distant monitor of that entire environment, and the capabilities that our dust instrument, which Voyager didn't have one, and the two plasma spectrometers, which are, no exaggeration, 1,000 times more sensitive than their equivalents on Voyager, built in the Stone Age of the 1970s, are just churning out tremendous data sets, literally 24/7, essentially 365 days a year. But I'm going to talk to you about the cherry on top, which is this close flyby of Ultima Thule. Our objectives were, this is the first time we'd ever been to something like this, not just something this much farther out in the solar system, but an object that we know is a bedrock sample of the distant solar nebula, and which is a relic of the early days of planet formation. So for those of you who might not know, solid planets form primarily through a process where small things grow and grow to become bigger things and eventually become a planet. The comets are a great example of early material from that era and things that had to accrete from stones and boulders and so forth, house-sized rocks. And for example, Rosetta's comet, it's about 5 kilometers long, went through that process. But that comet and every other one we've ever seen has been heated repeatedly by orbits close into the sun, which changes their chemistry, which changes their surface appearance, which changes their structure. And so although they have a lot to teach us, they're very highly evolved. We'd never been out to the original birthplace before to see one caught in the wild. And Ultima Thule is not only primordial and always been cold, it's never been close to the sun, much better preserved. It's also enormous compared to a typical comet. Compared to Rosetta's comet, for example, this object is 7 times as big and 7 cubed times as massive. So it's just a tremendous opportunity to go and be able to study the geology, the composition of an object like this, to look for whether it ever had an atmosphere, particularly early after the formation days, to search for satellites and rings around it. And those were our primary objectives. Now, I want to give you an idea of how tough this is. I'm going to show this little 10-second video. This is planet Pluto, and we're going to zoom up on Sputnik, the big glacier, and there's Ultima, which is about the size of a typical mountain block on Pluto. So it was our job to hunt this tiny thing down in the darkness of the Kuiper Belt, 1 billion miles beyond Pluto, and get it right on the first try. And so we spent 3 years from the fall of 2015 to the fall of 2018 preparing plans to do this. And we were using every tool available to us. We had enormous amounts of Hubble time to track Ultima Thule and refine its orbit. We single-handedly, through the force of Mark Bowie on my science team and his chief lieutenants, along with many dozens of volunteers, developed a technique to actually get in the shadow of Ultima Thule, to do stellar occultations, to pin down its position and to search for debris around it, with a level of accuracy unlike anything that had ever been done before. Yes, people had done occultations of asteroids, but they are typically 40 times closer and 40 times bigger on the Earth than what we were going after. And through the use of the European Space Agency Gaia star catalog that gave us a very accurate reference frame, we were able to get 3 of the 4 occultations with good data and really pin down the orbit. And at the same time, we were planning these flybys that are all done remotely on the spacecraft. There's no commanding going on back and forth because the light travel times are so long. If you want to send a command to the spacecraft, it takes 6 hours from the time you launch it from a deep space network antenna till it gets up there. It takes 6 more hours to find out if it worked. So we put a pre-programmed, a canned sequence of activities on the spacecraft every few weeks, and it executes. And around the time of flyby, it's much more intensive activities. We spent years planning both a flyby and a backup flyby in case we had to divert because of hazards. And then we had predicted that that LORRI camera that Steve works on could, in a stretch, if we pulled out all the stops, detect Ultima Thule, this target the size of like greater Washington, D.C., but draped in velvet, black velvet, because we know its albedo, its reflectivity is very low. In the light of the Kuiper belt, which is 2,000 times fainter than when you stand outside this afternoon, that we could detect it from more than 100 million miles away. Now, that's the good news. The bad news is our direction of flight and where the target is in the direction of Sagittarius, which I think most people in this room know is the galactic center, the densest star fields in the sky. So we are looking for this faint little ember at 22nd magnitude in August of last year against these star fields that are ridiculous, just completely obliterated with other stars. And we had predicted exactly which pixel Ultima Thule should appear in if we had the navigation right. And if it was off even 1 pixel, it would be bad news for our fuel supply. So we woke the spacecraft up from hibernation in June. We got a lot of data off the spacecraft, cleared the recorders, erased, got ready to fill them up with Ultima Thule data. We conducted some other science, some tests on board the spacecraft, made sure everything was good to go. Then in August, we began using the LORRI camera to spot Ultima Thule for optical navigation purposes. And that was very successful. Here's the star field. Actually, no, this is not the star field. Here's one little tiny piece of the star field in the middle of the center of the field of view. And we'll see if I can make this work. Okay, watch Ultima Thule appear and over several weeks cross the field of view. Can we do that? This should run. Oh, here it's going to go. You see Ultima Thule getting brighter as we get closer, right? Emerging out of that little star cluster. There it is. That's a period of about 90 days, by the way, all that relative motion. Anyway, it did turn out to be dead center near that exact expected pixel, and we tracked it, and we did course corrections in October and November and December to get there. This is our plan, was to fly over to the north, to the celestial north of the target. We come at it with the sun at our back at what we call low phase angle. So the sun is almost shining directly on the target, and we're coming out of the direction of the sun. And our goal was to approach much closer than we came to Pluto. In fact, 3.5 times closer, which made it more challenging. Not only to navigate there, but then to get all the observations right, because the tolerances are lower as you go closer and closer. You have to be more and more exacting to make sure that your fields of view are on the target, not half off the target or all the way off the target. So we plan to fly as close as 3,500 kilometers. Let me put that in perspective. The closest point to Pluto was about as far away from here as Tokyo. And for Ultima Thule, it was about as far away as Los Angeles. So dramatically closer. And then with the LORRI long-range camera, our highest resolution imaging at Pluto was 80 meters per pixel, and we plan to get down to about 33 meters per pixel at Ultima Thule. And we did. We put together a very carefully choreographed 12-week observation program with a very high-intensity 9 days, and within that, 1 day of furious activity when we were close enough to map the target, map its composition, to search for satellites, search for rings, search for past or present atmosphere, see if it interacts with the solar wind, take its temperature, try to measure its radar reflectivity. And this was a computer sequence that between design and then refinement and test and audit and everything that went into it took 3 years, but we only had one chance. And this flyby really was a stretch in every way. I showed you the size of Ultima Thule compared to Pluto. It's tiny. To try and track that down was an enormous challenge all by itself. And we didn't know if it would have a hazard debris environment, a lot of stuff left over from the formation days, that flying past it at 32,000 miles an hour could be fatal to our spacecraft. So we had to put in place a hazard search. And we had a hazard search team, and they had 7 different simulations that were multi-day simulations of how we would reduce the data and make decisions about whether we would have to divert or not. The lower lighting levels meant the instruments had to strain much harder to develop the signal to noise. And they didn't have as much time because the target's so much smaller, you have to do everything closer in. And then the communications times that I spoke about earlier, 6 hours each way, 12 hours round trip. Compare that to Pluto, 9 hours, which itself is a long time, but just that everything's getting harder. And then the spacecraft has lower power levels because the plutonium is generating less heat and therefore less electricity every year. And that made it harder because it meant that we had to very carefully choreograph what's turned on and what's not at any given moment to never get above that 190 watts that the RTG, the power generator, could produce. Because if you ever go over that, the spacecraft browns out, and then you will lose observations while it's recovering. So all of those 5 factors conspired to make this dramatically harder to do. And as I said about Pluto, it's the same for everything New Horizons does. You get one chance. There's no way to do a U-turn and come back. There's no New Horizons 2 following a few months behind. You get it right or you don't. And this is what you saw if you followed any of this flyby. It all worked, and you saw our press conferences and standing ovations, and maybe you saw some media and cartoons and things like Prickly City here. But I thought I'd take you back behind the scenes and show you what it was like. So I'm going to show you a few pictures on the behind the scenes part. And these 3 are all made in our geology and geophysics back room at the Johns Hopkins Applied Physics Lab. And the first one I'm going to show you is live, taken the moment, not a minute later, but the moment that the first high-resolution image of Ultima Thule, not a smudge or a fuzzy thing, but the first really good image went through the computer processing and popped up on the big screens in the geology and geophysics room. And the people in that room, like the rest of the New Horizons crew, have been working to make this work for 3 years straight. And here's the first image at 3 in the morning. And you can just see the emotion in that room. And then we had this amazing object that I'll tell you a little bit more about in a couple of minutes. Here's another picture. These are the leaders of our, the guys that were navigating us to the spacecraft. And when that picture showed up with Ultima Thule dead center, the whole thing broke out in hugs. And then within a few minutes, of course, all the nerds are on the computer because it's time to get down to science. This is what we saw on New Year's Eve, first resolved image of Ultima Thule, 21 miles and 33 kilometers in length. We later refined that to 35. We called it a bowling pin. And we had already had good information from the stellar occultations that it was either going to be a close orbiting binary or what we call a contact binary, in which the 2 objects that had been orbiting were now physically resting on one another. And we still couldn't tell one day from the flyby, but very quickly after that we could. So meet Ultima Thule. This is the real deal. You are looking at history. 4 billion-year-old object from the birth of the solar system. It's about 20 miles long, as I just said. If you're familiar with Rosetta's comet 67P Churyumov-Gerasimenko, it would very nicely fit in just this hole in the ground on on Thule. And we named the lobes Ultima and Thule, as I'll show you in a minute. And one of the things I want you to notice right off the bat is how undamaged the 2 objects look. Right? They look completely intact. The typical collision speed in the Kuiper belt for this orbit population is about 300 meters per second. So if these 2 objects had formed far apart and come together in a collision like that, they would completely shatter. They must have formed very close together because they had very low relative speeds. We can't find fracture zones. We don't see any strong signs of violent deformation. So that tells us that their merger was a gentle process. I'll say more about this in a few minutes. But they must have literally formed together, like peas in a pod, and then through some process, which I'll talk about, come together into gentle contact. And we use the term docking a lot because it had to be so slow that it was almost like spacecraft docking. And when I put the first paper in, it's going through refereeing to Science magazine, they came back and the editor said, don't use that term docking. That's what pilots do. It's not what inanimate objects do. So it's all about gentle mergers. Here's a little bit of terminology. The big lobe we call Ultima, the little lobe we call Thule. I mean, we don't have much imagination. The object was Ultima Thule. It's 3 in the morning. We're all tired. All right, we'll split it up. The neck or the collar between the two objects where they're joined is this amazing bright ribbon of material which we do not understand, but which is very prominent, and there you see it. Here's an approach movie made over about a day, and you can see that the rotation axis is pointed nearly directly back at our direction of flight. So it looks like a propeller spinning. We derived a period for this. It's 15.92 hours, fairly typical of small Kuiper belt objects like that, but the polar obliquity, the fact that its pole axis is tilted 98 degrees, just about like the planet Uranus, right, on its side, is an important clue to its formation. When we look in more detail on the surface, we see all kinds of interesting albedo markings. Now, everything you're looking at here is dark. Remember I said black velvet. The typical reflectivity on the surface is about 7%. 93% of the light that falls on Ultima Thule is absorbed by that surface. But there are places that are brighter and places that are darker, and they range from about 5 to 12% reflectivity. And here in an image where we've stretched the contrast so you can see it better, you can see there are different classes of these bright features. There are ovoid or more or less circular bright spots, and there are a lot of them if you look carefully. Some of the most prominent ones are pointed out there. There are what we call bright curvilinears, so they're elongated tracks on the surface that are bright. The most notable of which is the neck itself, but it doesn't show up as well here, but I'm pointing at some of them. It's much better on the little screen down here. And then, and this is going to be even harder for you to see, but there are broad zones that are higher in reflectivity than the material surrounding them. And since we see many of each of these three types, there's got to be some physical process that creates each of the three, which we would like to understand. And there are also dark zones. There are only one or two dark spots, and there are no dark curvilinears, but there are some dark zones like the one that's shown there. Let's talk about cratering. We normally use cratering to understand the age of objects, and when a surface is lightly cratered, it means it must be young. Unfortunately, because we came straight out of the direction of the sun and the phase angle was very low, meaning the sunlight was shining directly down on the target, there weren't many shadows to help us pick out craters. And we have a couple of cratering experts on our team, Stuart Robbins and Kelsey Singer, and they've been doing exactly that. We see groups of craters in a line like that we don't think are actually due to impacts, because you'll notice not only are they all correlated together spatially, they're in a line and they're all the same size holes in the ground. Those are much more likely to be collapsed pits or sublimation pits that formed endogenically, not exogenically. But there are lots of things that might be craters on the surface. And we have completely enumerated all of them and measured their diameters, and we can pretend that they're all craters. What if they're all craters? So Kelsey's done that, and I'm going to put these plots up. These are nerd plots with log plots. But what's plotted here, without understanding the scales or what an R plot is or anything else, she's taken 4 different measures of confidence for every potential crater, from I'm really confident it's blue down to it's, are you kidding me? and plotted the number of craters as a function of size. Okay, and you can see that all 4 results are roughly the same, but what's more important is over on the right, those red lines represent the kind of distribution you would expect if the region of space out in the Kuiper belt where Ultima Thule orbits is in what we call collisional equilibrium, where it's a shooting gallery like the asteroid belt. And you can see that the plots that Kelsey's made from the actual data don't look anything like that. They look more like the blue lines that were the prediction for what we would find if the region near Ultima Thule was like what we found at Pluto at the inner edge of the Kuiper belt, with a dearth of small kilometer-sized and smaller objects and nothing like collisional equilibrium. So we confirmed that result. And then, we try to eke everything out of the data so we can plot the profile around the limb of all the topography. and we can subtract from the distance from that profile the general shape. So you take out the low frequency information that's just about the more or less figure eight shape of the target, and find out how tall the mountains and hills are that are protruding above the surface. And here we see the Ultima lobe on top and the Thule lobe on the bottom. The Ultima lobe has about 1 kilometer of relief. It's about 3,000 feet. The Thule lobe has about half that. Taking that and knowing something about the local gravity, which we can calculate or at least guesstimate, and guesstimating the density, we can actually derive some interesting constraints. One of them is a constraint on the strength of the material that it would take to hold those features 1 kilometer high up over billions of years without them slumping under their own weight. And what we find is that the strength of this material could be as low as talcum powder, right? It could be like a fairy castle structure. We've been making geological maps, and this is a complicated pair of objects. We hit the jackpot in terms of the geology. There's a lot it has to teach us, but the thing that I want to concentrate on here today, before we turn to questions in a few minutes, are the things that those arrows are pointing at. I'll go back to the geology map and point out that on the big lobe Ultima, there are 8 of these roughly similarly sized regions that abut one another. Typically, their interfaces are bright material, like I showed you earlier. And what could they be? We have a lot of ideas. Those could be the elements out of which it was made. Or they could be the result of some sort of subsequent evolution of the object, for example, by bottling up the heat of radioactive decay from aluminum-26. Or it could be other things. And we're still working on that, and some things are working out and some things aren't. It's early days. All this data is only a couple of months old. But take a look at the other lobe. You don't see any of that, those same size pieces on the Thule lobe. Why is that? If they were formed together and they have the same reflectivity and they merged at low speed, meaning they were formed from the same part of the nebula, why doesn't Thule look anything like Ultima? Well, it just might. There's some actual hints of similar units on Thule, but it looks like this big feature, the big crater, basically obliterated and resurfaced a lot of Thule early in its history, and it's just masking what's probably beneath. We make color images with the Ralph camera on board. There's in the top left, you see a Ralph color image. It's not nearly as high a resolution as a Lori panchromatic or black and white image. So what we do in the computer is we take the Lori high-res image and the Ralph low-res color, and we drape one on top of the other, and you get the result on the right. And then if you look further to the right where it says most prominent color variations, what we find is the 2 lobes are not only similarly reflective or unreflective, but they also have the same color to within the error bars. And it's only when we stretch and stretch and stretch the data that we can start to find a few places, like are pointed out in those arrows, that are not quite the same color. And the way that we do it is we use red and blue to indicate the different spectral slopes, but actually nothing on this surface is blue. Everything is red or less red. And when I say red, I mean as ultra red as anything in the solar system. And the stuff that's less red is still very red. We've also got compositional spectra now, and we have tentative identifications of water ice, which is not surprising, and methanol, which is very common in protosolar disks, and may have been from the material out of which our protosolar disk was made. Here's a little better look at the color. You can see that the only regions that really look a little bit different are basically the neck, this thing we call the thumbprint. It's kind of bluish here, but remember, just less red. And then this canyon or gash, which is also blue. Don't believe anything around the limb because that's just an image processing artifact. But what's most amazing about Ultima Thule, other than just thinking we went 4 billion miles and 4 billion years in history, but scientifically what's most amazing is the shape of the object. First, a contact binary. Secondly, an intact contact binary, But what really surprised us as we started to get more and more images in from different angles was the fact that these two lobes are not spherical. They're like pancakes or discs. And you can see that very clearly in this sequence where we're taking the images and rocking them back and forth. And how, I mean, no one expected that. There's no model that predicted it. How that formed, we got a lot of ideas. And we can talk about that in Q&A. But it really must be a very important clue to the origin of the object. So here's our best computer-generated shape model. And I realized that to some people, the one in the lower right does look like the Starship Enterprise with the engine nacelles taken off, but it's not. This really is a very surprising object. All formation models generally produce things that are roughly equidimensional. And you think of all the asteroids that you've seen. The fact that this is a bilobate or object or contact binary is alone amazing. But the fact that they are so thin in that third dimension is also amazing. And get this. Look, you might have noticed this, but the three principal axes are also very well aligned. That's another clue. And what probably happened, I need both hands, is that as they were orbiting one another, their mutual gravitational tides caused the objects to co-align and lock up in that stable configuration. They didn't form like this, or like that, or like this, or in some crooked way. They literally merged as if someone, can I say it, docked them. Right? Now, please don't tweet that. I once gave a talk in Canada to the Royal Astronomical Society of Canada after the flyby of Pluto and referred to the geology by saying Pluto is alive. And the next morning, I'm getting calls from NASA headquarters. What did you tell them? I meant geologically alive. Okay. But this is an amazing, if you do it in a computer and you calculate the odds this would happen by chance, it's like 1 in 100. So it's almost certainly strong evidence of this tidal evolution that caused the object's principal axes to align before they actually merged during the late stages of that orbital evolution. Now, let's talk about the merger itself. And I don't know how to start this video on the left from here. But this is what happens when you make a collision at 10 meters a second, which is like a car crash speed. The two objects basically just glance off each other. And because that 10 meters a second is high compared to either of their escape speeds, they just go off to infinity. And by the way, this is a very sophisticated model developed by Derek Richardson at the University of Maryland and his students, one of whom is shown there, that includes tens of thousands of finite elements and he correctly represents the strengths of the objects, which we put in as a free variable, their mutual gravity, and friction in the collision. So this is a lot of fidelity. It's not just a cartoon. This is a calculation done on a supercomputer that takes days to complete. So what if we make the speed slower, 5 meters a second, like a fender bender? That's the next one, which I hope we can show you. Maybe the back room can help. So 5 meters per second, what happens? Now the collision speed is low enough, we need to start that, yeah, that they're not going to fly off to infinity. But on the other hand, the way they merge doesn't look anything like the Ultima Thule that we see at 5 meters per second, with all that physics in there correctly represented. What did happen? Here's what happens at 2 meters per second. They dock. I know science thinks it's a 4-letter word. Okay, anyway, so we think we've got a handle on what's happening. How did they get to such low speeds and such slow rotational speeds? What was probably going on is there was a large cloud of material out of which these are the two dominant players, and they were ejecting other objects from the swarm, and in doing so, shedding angular momentum and orbital energy, and hardening the binary, meaning they were moving towards one another as a result of ejecting the smaller bits and pieces. And here's kind of a cartoon view of how that might all get put together. So there's the swarm on the left, there's the pair that are now close to one another and interacting tidally, and then they merge or dock. Well, whatever it is, I can tell you that we hit the jackpot again, just like at Pluto. Ultima Thule has a tremendous amount to teach us about the formation days of the early solar system, and we just couldn't be happier. And we're just like kids in a candy shop with the data. The data transmission itself will continue through late next summer to get everything to the ground. And the analysis and paper writing will also continue. We're currently funded through 2021 to finish the first extended mission, and we'll propose a second one. But we have a long way to go. Every week, new data lands on the ground from one instrument or another. And I like to liken the process to being ER docs. As a new patient comes in, you just triage the patient and move them along, and then the next patient's coming in. In the same way, we get new color data or new high-resolution data or new plasma data or new this or that every week. And we make a quick analysis of it, and then we move on. And so we're only scratching the surface of what's there to do. And when you combine that with the fact that 80% of all the bits are still on the spacecraft, that we've only been at this for 3 months out of 20 months, stay tuned, because there's going to be a lot more to come out of this flyby and its results. These are just some of the mysteries that we've already identified about how the thing formed as a binary, but how the two individual lobes formed, how they got aligned, the strange albedo markings, the nature of those mounds or like-sized units on the ultima lobe, the degree of cratering that we're still uncertain about, and the origin of the color variation across the surface. So we got a lot of work ahead of us, but we're very happy about how well it all turned out. If you want to hear about New Horizons and what might happen next, I'll say a few words about that. The spacecraft is still very healthy, 13 and a half years after launch. We're using no backup systems owing to failures. Sometimes we use backup systems for engineering reasons, but we don't have anything broken on the spacecraft, and all 7 scientific instruments are working perfectly. The power supply on board can run us into the mid or the late 2030s, at which point we'll be more than twice as far from the sun as we are now. We'll still be in the Kuiper Belt until 2027, and we have just about exactly as much fuel left on board as it took to target Ultima Thule. So we would like to try and get another flyby, and we think we got a fighting chance to do that. You remember I said that we're very happy that when we got off the Atlas on the first day of flight, that it delivered us much more precisely. So we pocketed a lot of fuel that we didn't have to use in initial course corrections. And that's what's made it possible here, literally 13 or 14 years later, to think that we've got a good shot at one more flyby to see another Kuiper Belt object, probably a couple of billion miles further out still, that we have not discovered, that we will have to search and hunt down, and which will be even harder than what we just accomplished. But the New Horizons team is an amazing group of people and very dedicated to every aspect of this project. And so, onward, New Horizons, and thank you very much. Oh, it's a stool. I can actually sit and take questions if there are any. Right in the front. Yes, sir.
When you were talking about it being like talcum powder, like covering, is there any sense of how deep it is? Is there that looks like a crater rim on the center of Ultima?
The very surface is probably churned up by micrometeorite impacts, and is certainly likely to be like almost strengthless. But it could be that the entire object is that way, that the entire structure is gossamer. Who else? Right there, yes, sir.
This is back to Pluto. I can't imagine, I wish you could describe what happens when you have the computer reset just before you arrive.
Okay, so the question was, he said, let's go back to Pluto, and I can't imagine what it must have been like when you had the computer reset. For anybody that doesn't know, 10 days before we arrived at Pluto after more than 3,000 days in flight, the spacecraft went offline. I get a phone call on my cell that we lost contact with the spacecraft. This is actually the way that our book begins, is on that afternoon, and what that was all about. Because I also couldn't believe that this was happening after a flawless 3,000-day flight and 10 days out. But it was a massive and heroic effort by our team. It was on the 4th of July, by the way, which is, everybody expects fireworks on the 4th of July, not this kind. And so we have a phone tree, and phone calls started going out within minutes, and the entire team assembled, the engineering team and the flight control team and others, and we went into a round-the-clock 3-day effort. And it was just like you saw in the movie Apollo 13. People were sleeping under desks, and they were going with cat naps for 3 days and eating out of candy machines. And we had, help running out to local fast food restaurants. And they basically did 6 months of work in 3 days to put Humpty Dumpty back together again. It was an amazing, amazing effort. And they saved the day. It could have been New Horizons sailing past Pluto and having no return. Yeah, okay. This lady.
Hi.
Hi.
You and your team have done so much to inspire people with Pluto and New Horizons. What would you like educators, science communicators, others to be able to continue to communicate and share out for you and your team?
Wow. So you asked what should you're an educator? Yes. Thank you for your work.
Thank you.
What should you communicate? Well, I probably have a long list, but I'll just give you 3 items. First of all, scientific discovery is something that's unique to human beings on this planet. It's something that turns out we're really good at, and I hope that you will engage and enthuse your students to go into STEM careers, because we need more of that to power the economy. Secondly, New Horizons is a risk-taking mission in many ways. We took the risk of not being able to meet schedule or cost or not succeeding technically. No pain, no gain. It'd be great if you could teach about prudent risk-taking, right? And then there's that thing that I was just being told about in the hall today by somebody who says that teachers are required to teach that there are 8 planets, which I have a problem with, since we're discovering... And not just 9. It's not about Pluto. We're discovering that the solar system was really good at making lots of planets, most of them small. And it's completely ironic that astronomers are afraid of large numbers. I'm going to be giving actually I'm on the 29th of April in Washington, D.C. at the Philosophical Society of Washington. I'm debating Ron Eckers, who was the IAU president in 2006. Shred. Okay, let's see who's next. Dead center, yes ma'am. And I'll come back in the back rows in a sec.
First of all, I loved your article in Astronomy in which you gave an argument for not doing away with the term planet. That was classic.
Well, thank you, and thank Dave Eicher here, from the editor of Astronomy, who's also of the same opinion.
Do you and David have a follow-up book plan, maybe called Following New Horizons?
We don't, as a matter of fact. But the book, Chasing, is going to be released as a paperback in May, on May 22nd. That's the next step, and then we'll see about a second edition with some updates. Well, we could do the director's cut, right? Because we kept all that. There's a lot of good stories in there. I'm going to go further back in the room before I come back in the front. Yes, ma'am.
Hi, Alan. Is New Horizons collecting any data or imaging on its journey to its next potential object?
Yeah, we do that all the time. The in situ, or the plasma and dust instruments, operate round the clock. We very rarely turn them off, very rarely, like 1 or 2% of the time. So they're collecting this amazing transect record across the solar system. And then we use the LORRI camera to look at other Kuiper Belt objects and dwarf planets all the time. We just finished a suite of doing that, and we also did some look-back observations of Pluto last month to look for whether the hazes that are particularly easy to spot from behind have changed significantly over the intervening almost 4 years. We have our next set of Kuiper Belt observations scheduled for a really intensive period in late August and then in the beginning of September. Okay, who's next? How about way over there? Yes, sir. Huh? Say again?
I watched the live presentation on Jan 1st when you guys were expecting the countdown.
Oh, great.
Gave me a lot of goosebumps, so thank you for that. It was an amazing journey. So, two quick questions. How long do you think before you can keep going on with this project, like far in the future? Do you expect it to image after it goes interstellar? New Horizons. And the second one is there a landing mission in Pluto coming?
Is there a landed? Okay, let's do all that. So first, future of New Horizons. I don't think there's any reason New Horizons shouldn't, from a technical standpoint, be able to operate into the late 2030s, maybe longer. Originally, we thought we could operate the mission into the 2050s. But when we were developing New Horizons, one of the things that came out of the blue, and some of you might remember this from the news, but it's a while back and it was a little obscure if you weren't in the middle of it, was that the institution that produces the plutonium dioxide that fuels the power generator is Los Alamos National Lab in New Mexico. And in the early 2000s, there were 2 shutdowns of the lab, one due to a safety violation and another due to a security violation. Neither had anything to do with New Horizons, but they had great consequence. And there was a point in time when we didn't think we could get enough nuclear battery fuel to do the mission. We really thought we couldn't. And NASA really jumped in and helped and found leftovers from other missions and some calibration supplies that all went in. But we ended up launching with about 50 watts less than spec for the nuclear battery. I said 250 watts, spec is around 300. And that works out to about 13 years of mission life. So it used to be, and when we proposed it, it was going to be kind of a stretch goal to get to 2050, and now we'll be lucky if we get close to 2040. However, there's lots of good science, and we're the only spacecraft out there to do it. And we are going to propose to NASA next year to revamp the flight code on board the spacecraft so that we can use the Lori camera again to actually hunt our own targets from inside the Kuiper Belt. Nothing like this has ever been done except in a sci-fi movie. It's true. And if we can pull that off and we can find something over the next 8 or so years before we leave the Kuiper Belt that we can reach with our fuel supply, it will necessarily be a flyby on warning. Remember, we could only spot Ultima Thule about 5 months before the flyby. We can strain a little harder. We have a new capability on the Lori camera. Maybe we can see things 6 months in advance, but what it means is we'll have to write the flight code for the flyby and put it on a shelf, fully tested. And then when we spot a target and confirm and fire the engines to go there, we'll have to pull that off the shelf and implement it in a matter of weeks, which will be pretty exciting. Nothing like that's ever been done before, except in the movies either. So I'm pretty excited about developing all that and trying to pull this off. There's no guarantee it will work. I mean, I'm sure we can write the software, but there's no guarantee the Kuiper Belt will cooperate and give us targets within our fuel reach. But, everyone in this room and everyone in this country, paid to get New Horizons out there, and it's perfectly working. So we want to get the most out of it. And that's our plan. And if I have anything to say about it, we're going to try very, very hard and hopefully succeed. More questions? Right there, yes, in the red.
In the slide, New Horizons full trajectory, the path curves before it gets to Jupiter rather than going around the outside. Jupiter's on the outside of the turn. Is that just an error in the slide?
Oh, it's just some artist. I mean, it's not an engineering diagram. Don't worry. We didn't discover any new physics. Okay, let's see. Are there people in the back that have their hands up or not? Is it only people in the front? Okay, yes, that's as far back as it can get. Yes, sir. Dead center, standing up.
Quick question. During the time that you were targeting Ultima Thule, what was your time window that you could do high-resolution data capture?
Right. Only from about the distance of the Earth's moon inward, which really just means the last couple tens of hours, right through the flyby. And as soon as we pass close approach, then we're looking at the night side, and there's not much to see. it's in darkness. Well, all the very best high-resolution data sets, which are now on the ground, by the way, all those were made in just a period of about 4 or 5 hours. And we had 10 close approach observations made during that period of time. Okay. With the iPhone? Right. Mm-hmm. There is. So he asked whether there's an archive of New Horizons data that he can get his hands on. And this is the way it works. For LORI images, which are easy for us to deal with on the fly as they land, we put them up on our project website, which requires no password, every Friday if there are new LORI images. They're there, and you can click on them and download the JPEGs every Friday. For everything else and the LORI, a very carefully calibrated and highly documented version of the data goes to a system called the PDS, or Planetary Data System, and is archived for people to use now and in a century. And every planetary mission is required to do that. And it's a very careful process. You don't just turn things in. Then they have peer reviewers, and they give you homework assignments, explain this better, or sometimes they find a mistake in a calibration or something. And so we end up, when we're done with each step in this process, with something you can really count on for the ages. And New Horizons, our next data delivery is in June, and then the one after that's in October, and the one after that's in April of next year. And it continues every few months as long as we're funded to do it. And anybody can get an account on that system. You don't have to be a NASA person or a card-carrying planetary scientist. Yes.
Was that analogy noticed by your team, or is similar math used in that simulation?
I think you asked 3 questions. The answers are yes, yes, and yes. and in fact, this kind of process has been known or predicted in computer simulations of planet formation for years. So we're basically providing the confirmation that something like that actually physically happened in the solar system as predicted. Okay, let's go way over on the other side of the room. And how about in the front row?
We know about the plaque that was put on Pioneer and the record player that accompanied Voyager. Was there any thought about putting anything special on New Horizons, some type of message or
Yes.
notation?
Okay, so how come we don't have a Voyager plaque or a Pioneer plaque? You're looking at the reason we don't, because people wanted to do that, but when I talked to the people that did it for Voyager and for Pioneer, I found out how involved in terms of political correctness that became. And we were really under the gun for schedule, and I thought it was better to get a spacecraft to Pluto than to get a spacecraft maybe with a plaque that didn't go to Pluto, or maybe just sitting in Florida, not able to launch. So I vetoed that whole idea. Now, we did put 9 things on the spacecraft we call mementos, and I've written about it before. Most famously are some of Clyde Tombaugh's cremains, a couple of American flags, a couple of CD-ROMs, things like that, but no specific message meant for others. However, there's some clever ideas about how we might do that in the future, and you'll just have to stay tuned. Okay, right here.
You compared the pristine nature of the Kuiper Belt objects to, say, things like comets that have been heated and cooled and whatnot as they pass by. Yesterday, Jim Green talked about the formation of the solar system. Things may not be where they once were.
Almost certainly.
Is there anything that indicates Pluto, Ultima Thule are not where they once were?
There's a large body of evidence now that the giant planets rearranged where they were in several different ways in the very earliest stages of the solar system's history, and that because they are so muscular gravitationally that they caused other objects to either be ejected, like to the Oort cloud, or to be pushed out. In fact, modern planetary formation theory has Pluto forming about half its current distance to the sun and having been pushed out. We have very strong circumstantial evidence for that. Somebody asked me, and I forgot to answer, if there will be a Pluto lander. I'll be very happy just to get an orbiter, but, and we're working on that, but over time, when there are more missions and we can get down on the surface and even the subsurface, we can develop specific information that'll tell us if these dynamical models are correct. Who else? We have time for maybe 3 more questions. Yes, ma'am.
Kind of a more general one, but do you have any advice for someone who knows they can do these things? They're just kind of starting out in like astronomy and astrophysics, but say it's a late bloomer of sorts, only getting to get into these things as an adult, but realizing that they can do them because maybe like not learning the way normal school is taught, may or may not go to school for it, sort of thing.
Well, she asked if I have any advice for late bloomers. I have a story and some advice. The first story is that I was a late bloomer, so I'm sure it can be done. I first went to grad school and studied aerospace engineering, and I went off and worked on spy satellites and some NASA projects, and over time found that I liked science better, but I had a house and a baby, and it wasn't very easy to go back to grad school. Eventually, I found a way, and then graduated about 8 years later than my cohort to become a scientist and start over at the bottom of a different field. So it can be done. But my best advice, if you want to be involved in the space enterprise, almost every line of work there is represented in the space enterprise. And whatever your skill set is, whether it's engineering or science, or whether it might be accounting and project planning, or whether it might be public affairs and public engagement, there are hundreds of career specialties. So I would just say find where your heart is, what you like to do the best, and go do that. Don't force yourself into the thought that everybody in this business, are the ones that do the math the best. Okay? We got lots of those. Our new NASA administrator, Jim Bridenstine, a lot of people thought, what are we doing hiring a congressman to run NASA? I never thought that. First, I knew Bridenstine for a couple years, and I was super impressed with his abilities and his background. But secondly, last I counted, NASA has 18,500 engineers and scientists. What difference does one more make, right? Well, I thought we really needed was somebody who knew how Washington works, and he's turning out to really be doing that very well. So that just shows you non-traditional skill set can be very important. So follow your heart. Right here, yes.
On New Horizons, you mentioned the LORRI camera so many times. Is that the camera that recorded all the images you see on Pluto, or was that just also comparable?
Yeah. So the question was, did LORRI record all the images you see on Pluto? Not at all. The Ralph color camera, which also has black and white, is also used. It has a wider field of view, which is important for some kinds of observations. And LORRI has no color capability. So anytime you see an image of Pluto or its satellites or Ultima Thule that's made in color, that's a Ralph image. I think I can do 2 more. Okay, right here. Yes, sir.
So, after, when we went by NEAF, we went by Pluto, you talked about the announcement that the data sets that were being downloaded would still provide real science
Yeah.
long after we did the flyby, and similarly for Ultima Thule. As you get these data sets, are there anything that you can tell us that you guys are thinking might come out of those data sets that we haven't thought about yet, or new ideas, new thoughts that might still be hidden gems within the data that hasn't been examined?
From Pluto.
From,
Yeah.
yeah.
So the question is whether there might be big discoveries coming out of Pluto data in the future. I can guarantee you there will be, because it's only now, we're only a year and a half since the last data came to the ground. And then the way it works in our business is people who look at the data have to write funding proposals. By the time they write them and get them approved and get funded, a year or 2 years goes by, because sometimes it takes a couple tries. Then they start their work. And all of the really detailed stuff for formation modeling, for the evolution of the geology, for the evolution of the atmosphere, all those things are just now getting cranked up by experts all around the country who've been funded to go milk those data sets. And even today, 30 years after Voyager did its thing at Neptune, Mark Showalter, who's on the New Horizons team, just discovered new satellites. It's just amazing. So I'm sure that a lot more is going to come out of it. Okay, last question. Right there, yes.
So, knowing what you know today, what would you have done differently if you had the chance?
If I had the chance, that's the wild card. That's the wild card. So, you know, in retrospect, I'm really glad that we didn't succeed at getting a Pluto mission earlier, because we would not have had the same amazing instruments. The technology, even in the early 90s, it was not the technology of the early 2000s. And, you know, you could always wish that we had more money and could have flown more instruments, but I think really, for our first mission, that New Horizons did it very well. And if I could really do it over and have any one thing, it would have been to have had New Horizons 2, so we could have seen the other side of Pluto and its moons. So that's my answer to the last question. But I'll be around for a few hours out in the gym over there where all the exhibits are. And so come and find me if you have more questions. And thank you for having me to NEAF again.
Thank you. Alan, thank you very much. A big thank you. Alan Stern, thank you.
Thanks, Vince. We're going?
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
National Oceans.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together, and putting your own vision on that and showing how you see the sky.
Hello there, I'm Lonnie Weegee with Celestron, and we're here live today at NEAF, and I thought I'd show you one of our new products. So what you're looking at is a brand new Roe Ackerman design. We call it ROSA. This is an 8-inch f2.0 imaging system. Now, one thing you'll notice about this, if you look at where we place the camera is designed to go on the front of the telescope. What we've done is we've taken a standard design and turn it into a ROSA design, and that means the light goes through the corrector plate, it hits a primary mirror in the back, it's reflected back up on the camera, and we get very fast wide field images. If you notice the camera we're using, it fits inside the objective so we don't block any of the light. This has been a hugely popular product for us. We're unique in this design. If you're interested in wide field imaging, if you're interested in the sky surveys, if you're just interested in a good, fast way to get started with astronomy, the Roe Ackerman is new. If you notice, we also have our new focuser on the back. This is something that's nice to have when you're doing astronomy and astro imaging. This will have steps that you'll be able to do the micro focusing needed to control a fast imaging system like this. We're very happy to have it here at NEAF. And come on by and take a look.
Hi, my name is Jeff Norwood. I'm the owner of Camera Concepts and Telescope Solutions. We're based in Long Island, New York, and we are, I'm proud to say, one of the supermarket vendors of telescopery. We sell everything and everything. From accessories to screws and bolts to things you need at star parties, all the way up to Takahashi's and you name it, all the rest of that. So at our booth here, we've been coming here to NEAF for over 20 years. We basically bring the entire store with us. So we've got lots of goodies, and of course, everything's on sale, great deals. Our website is www.cameraconcepts.com. Please visit us. We support what we sell. We've got experts in the field on staff to help you with astrophotography, all your visual aids that you might need. So thanks a lot, and bye.
Hi, I'm Kelly Beatty from Sky and Telescope. I'm a senior editor on the staff. I've been on the staff of Sky and Telescope since 1974, hard to believe. But I'm still having fun, and why wouldn't I? We're a very important part of the amateur astronomy community, just as NEAF has become a kind of essential go-to place each year for many thousands of people in the amateur community. We're here, we're one of the co-sponsors of NEAF, and we are dedicated to being a major part of that. You know, people think of us as just Sky and Telescope magazine. We're actually much broader than that in a couple of respects. One thing is we do a lot of outreach. We provide a lot of materials for amateur clubs across the country when they need materials to distribute at their star parties and such. And we also do some products that are maybe not what you'd expect from a magazine. I've got a couple here. We have a whole line of globes that we sell. They're really great. This one, for example, this black beauty is our celestial globe, which shows all the stars in the sky down to 5th magnitude. And then this is our new one, just about to be produced. It's a globe of the Earth, obviously, but it shows all total solar eclipse paths until the year 2100. So if you're the kind of person who likes to plan ahead, this is just the globe for you. You'll know where to be in 2024 and beyond. The other thing we do a lot of is tours. Speaking of those eclipses, we've actually got a whole bunch of tours that we do all over the world. We just had a tour finish in Finland to go see the auroras. It was very successful. This summer we have a tour of Chile coming up for a total solar eclipse. We've got an observing tour planned for Australia that is just going to be killer. So for all these reasons, Sky and Telescope sort of considers itself the essential guide to astronomy. And again, we've been at this for 75 years, so we really have a good handle on the amateur community. We're from the amateur community. We'll always be a part of it. And we are so grateful to the organizers of NEAF, Ed Seaman and the rest of the crew here for welcoming us every year and being such gracious hosts in this amazing setting where the sky is really the limit. So thanks very much for the opportunity to chat, and we'll see you here next year.
Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us.
We're live here at the NEAF conference in Suffern, New York, and we're from Lowell Observatory. And Lowell Observatory this year is a great year because we're celebrating our 125th anniversary. So 125 years of great discoveries, and that's really the legacy of Lowell. We've been doing important research from the discovery of Pluto to VM Slipher's recessional velocity work to current research using our Discovery Channel telescope to discover planets around other stars and a lot of other great work. So we're doing a lot of great things, and it's also a great place to visit.
And we're doing all kinds of neat things this summer to commemorate our 125th anniversary. So we have coming soon the opening of our Giovanni Open Deck Observatory, which is going to feature 6 modern telescopes fully dedicated to public observing. A great suite of instruments there and some nice interpretive locations to look at and learn more about the telescopes and astronomy. And then of course this summer we're also celebrating the lunar legacy for Flagstaff as we approach the 50th anniversary of the lunar landing.
And it really is a great time to celebrate the 125th of Lowell and the 50th of the first moon landing, and all the astronauts who walked on the moon trained in northern Arizona. And so we have a community-wide celebration at Lowell Observatory and other science centers. Even our businesses are getting into it, creating specialty drinks like the Earthrise cocktail and a special moon pie and all sorts of other great desserts. So it's a really great time from now through the end of 2019. We're doing this Lunar Legacy celebration, plus all the stuff we normally do at Lowell. And we're also opening this new open deck observatory that Danielle mentioned that's going to change how we do astronomy outreach, because we have big 32-foot long telescope to look through, plus this suite of state-of-the-art telescopes that that our visitors can really see what it's like that real scientists do, and also just the wonder of looking through an eyepiece and gazing in awe at the universe. It's just something that we as humans
And now, ladies and gentlemen, the hardest working MC in the cosmos, Vincent Coulihan.
Hey, thank you very much. And welcome back to the NEAF Talks for this afternoon. I want to welcome you, and I also want to take this time to extend a big thanks to Celestron for promoting this next speaker. It's truly an extraordinary opportunity. I'd like to give them a big shout out and applause because this truly is going to be great. Our next speaker, I have to say, maybe with the exception of the astronauts, has probably traveled the longest distance to get here, okay? And with that, I want to say that this opportunity that he has to offer us is extremely important, and it's a great opportunity, what he has to share with us. He is an accomplished imager. He shares a lot of his intelligence and learnings online through various media methods. And I would like to take this time to welcome to NEAF, Mr. Dylan O'Donnell. Thank you, Dylan.
Wow, there are way too many people here for this talk. Thank you for having me, and it's a real pleasure to be here at NEAF and meeting so many people. I feel like sometimes I'm in the backyard twiddling knobs and pushing buttons and ranting at a camera in the dark, and it's really comforting to know that I'm not the only weirdo, that I'm here with a room full of weirdos. When Celestron told me that I could come here and give this talk, and they gave me the brief, I had to ask them. I said, let me get this straight. You're going to pay for me to come to New York and talk to a room full of mostly Americans about how good I've got it in my hemisphere? I'm born for this. This is my shtick. This is my whole shtick. I was born for this moment. This is fantastic. So the title of the talk, of course, is The Tour of the Southern Skies. But as I was writing the talk, in my head, the working title was, ha-ha, my hemisphere could beat up your hemisphere any day of the week. I should also ask, can anyone understand a word I'm saying? Yeah. I realized that my accent's a little different, and I wasn't sure if it was like a New York thing, whether I just wasn't speaking loud enough, or if I really do sound like Crocodile Dundee. But why should you care what I have to say at all? At the end of the day, I'm just a guy with a telescope, just a guy who walked into a store and bought a telescope. If you Google my name, I've worked really hard over the years to make sure that I come up first, and I've been optimizing those results. I ego Google regularly, have my news alert set up. Unfortunately, there's one guy that will come up. He's an English footballer called Dylan O'Donnell. I've been working really hard to edge him off the page. He's recently changed his name, so I like to think that I've had something to do with that. But I don't want to bore you with just a normal slideshow. There's nothing more boring than talking about someone's travels or someone's slides in general. I have a master's in information technology, so my background is in computer science, and I'm halfway through an astronomy degree. But ultimately, I am just like you guys. I'm just someone who bought a telescope, and I really have to thank Celestron for the support they've been giving me over the years. This is just my Instagram, basically. This is the Instagram for the last couple of years, so you can see the improvement and the progression. This is a couple of years old now, but I've taken a lot of photos, and that's probably the only thing that really qualifies me to be here, other than the fact that I live in the Southern Hemisphere. That qualifies me more than most of you guys. I do have a couple of APODs. I don't really do it for APODs and award ceremonies and things like that. I give away my work for free as well. You can choose to license your work as Creative Commons, But I choose public domain because with public domain, people don't have to give you credit. They can take that image and they can use it for anything. And that means sometimes my images get taken and they get put on, flat earth stuff and they get put on anything. But it also gets picked up by news organisations, it gets picked up by all sorts of outlets who feel free when they're running to a deadline to use my images. So if you are an astrophotographer yourself, I do highly recommend considering public domain. Get your images out there for free. We're competing with NASA and they give their images out for free. So I don't see, I don't see why I can put a price on my stuff. I'm lucky enough to live in Byron Bay in Australia. It's this beautiful hippie paradise on the easternmost point of Australia. It's a kind of wealthy paradise now too. We've got people like Matt Damon and Miley Cyrus and Chris Hemsworth living in their multi-million-dollar mansions out there. But it has this real hippie ethos about the whole place. It's a really beautiful place to live. It's still illegal to smoke weed over there, but everyone does. But we are lucky to have the first sunrise and the first sunset in the country because we are that easternmost place. It's a special place for a few reasons. Because of this hippie ethos it has, it's very anti-development. So there are no buildings over 3 stories. So you can sit on the beach and look back and you just see trees. It just feels like you're in the middle of nowhere. There's only 6,000 people living there, but we have 2 million people just coming through the town every year. Someone in the 1990s decided to bury the street lighting, and this had this cool effect where you're in the urban streets and the street lights are just gone. You can see houses and you can see the Milky Way over the top of it. So very low light pollution. They don't like capitalism generally there, so they won't let McDonald's move into town, for example. But they're also afraid of fluoride and vaccinating their children, so it's a bit weird. It's a bit like San Francisco, where wealthy hippies reckon they can be a bit anti-science, which is a shame. And it's ironic because I care about science and I care about astronomy, and I'm the astronomer in Byron Bay. But when I tell people that I'm an astronomer, they say, "Oh, that's lovely, I'm a Virgo." They really don't care. So these are my skies. This is most of the reason that my photos are okay. I have good skies. I estimate for my house I'm probably Bortle 2.5, which is in between a rural location and a truly dark sky. The town has a small glow, and that's certainly a factor. But when you're looking east, you're looking towards nothing. There's nothing for miles and miles, like 8,000 miles. Nothing's there. So here I am, just some guy living in a hippie paradise, and I walk into a store one day and I buy a little Celestron 4SE, which at the time I thought was a really expensive telescope, and I was in for a surprise. And here's an image that I took riding piggyback on that telescope. I was doing everything wrong, so this is one of my early images, but you can see a really dense part of the Milky Way. But I wanted to show you this because I wanted to show you that even though I didn't know what I was doing and I was just starting out, it's super easy. It's just super easy to go wrong down there. So this is with a cheap DSLR camera, 4 45-second shots stitched together, showing from the core of Sagittarius all the way to Scorpio and Carina, and just blazingly bright. This is high above us, so it's not over on the horizon, it's like right up. So it's beautiful to photograph. The core area rises over the ocean and just goes straight up and then comes right down over the west. So you've got a huge segment of the night to try different things. And the Dutch astronomer Bart Bok, Dutch-American astronomer, he's famous for saying all the best stuff is in the southern hemisphere. Bart Bok is the guy who coined the term Bok globules. So if you've ever seen nebulas with Bok globules in them, they're named after that guy. And it's always nice when an American tells us that we're better. Now that might come as a surprise to Charles Messier, who observed and catalogued mostly from France. And you can see that he left a huge gaping hole in the middle, or the bottom, I should say, of his catalogue. He basically left us off the catalogue, which is sort of funny for us in Australia. We know that if something that we're photographing doesn't have an M designation, that it's something that you guys can't see. So we lean heavily on the NGC and the IC catalogue. Now this is me underneath Karina. I'm well and truly in love with Karina. I was calling Karina my girlfriend for a long time. She's very, very easy to fall in love with. And if you look at Wikipedia, it tells you that Karina was discovered in 1752 by a French dude, which is, I can guarantee you, it wasn't discovered by a French dude in 1752. It's been there the whole time. It's literally the brightest, biggest thing you can see in the sky. And we've known about it for a long time before that. So yeah, naturally it features in Aboriginal history and Aboriginal astronomy and tradition. Now I know you guys in America love big things. We're all about big things here. I don't know how you guys deal with those medium-sized servings. They feel like they are bigger than my internal organs can handle. But we like big things in Australia too. So we have the big rolling pin, the big sheep, the big banana, and the big prawn, which are classic highway icon truck stops. In fact, those are the directions to my house from Melbourne, if you ever need to know how to go. So, let's go through what you can see. Bullet point list for the Southern Hemisphere. We have the brightest, biggest nebula visible from Earth, which is Carina, of course. We have the brightest, biggest naked eye galaxy, which is a large Magellanic Cloud. You don't need any equipment to see that. The brightest, biggest part of the Milky Way, the core, of course. The darkest, biggest dark nebulas, the Coalsack Nebula, Emu, Rho Ophiuchus, and a whole slew of dark nebulas through those regions. And we have the brightest, biggest globular cluster, if you're into globular clusters. And we still get to see Orion upside down compared to what you guys see it, but we still get that too. So we get a lot of good stuff. This is a photo that I took from Western Australia. An important aspect of astrophotography, especially this wide field Milky Way stuff, is the landscape. And you guys here have a very diverse landscape. You guys have the Grand Canyon, you have mountains, you have snow, you have desert, you've got everything. And Australia has a lot of that too. We just don't have the big mountains that you guys have. And the pinnacles in Western Australia are beautiful. And none of this is locked off. You can just drive your car into it at any time of the year, any time of night, and just get out of the car and take photos. This image is interesting because I made a mistake, a beginner's error on this image. There's a setting in your camera where you can turn down the size of the image, and what that effectively does is bin the image, so everything becomes twice as bright, and that's what happened here. But I think it really illustrates just how bright and beautiful we have it down there. You've got the Coalsack Nebula up here, and of course the large Magellanic Cloud and the small Magellanic Cloud there. It's a beautiful example as well of constellations. I've always thought of as a bit weird. Maybe it's because I'm a new astronomer. I don't really care about the constellations. I know that's a bit weird to say. But when you're out there on a dark sky, good luck finding a constellation. You literally cannot make them out. Now, sometimes, and I've heard this story a few times, you'll be out there imaging or observing with someone, and you'll say, it's a beautiful, clear night tonight. Look how clear we've got it. And they say, yeah, it's pretty clear except for those clouds over there. And then you have to explain to them, they're not clouds, they're nearby galaxies. And that's funny, but that happened to you guys as well in the big blackout of 1977, I believe, in New York, where people actually called 911 because they thought the city was on fire because of this big trail of smoke across the sky that they'd never seen before. Oh, so Omega Centauri. Just for scale, that's Omega Centauri up there. And next slide, you can see it's big, right? You don't need any equipment to see that either. And that's Omega Centauri there. But you know, how boring are globular clusters? Well, you've seen one, you've seen them all. If I hadn't have shown you that last slide where it showed you the scale, a globular cluster is a globular cluster. But they do have some interesting science. They're kind of very mysterious scientifically. They're filled with old stars, but they don't follow the plane of our galaxy. So our galaxy is flat, the Milky Way is flat, but the globular clusters are all over the place. We don't know why, we don't know how they formed, we don't know how they evolved, they're a really strange object. So in that sense, they're very interesting scientifically. I should say how intimidating it is not to be here and talking or anything like that, but just showing images at NEAF to people who are experts in taking images. And so you guys probably already can see that my chip is tilted here and I have some out of focus stars there. So I'm going to admit to all of this stuff as I go. Now this shot is the Large Magellanic Cloud with no special equipment, just a DSLR literally out the back door. So I've gone out the back door, put the DSLR there, done a few 30-second exposures, and caught a comet flying past the Large Magellanic Cloud. Now I mentioned that I make my images public domain. So I take something like this, it's an event, I put it online, and the next day I had the editor from, or one of the article journalists from National Geographic take that image and publish it because he was doing a particular story on comets and that particular comet. Now, the elephant in the room, of course, is that you guys have Andromeda. I realize that Andromeda is the prototypical perfect specimen, and our specimen is not so perfect. It is the Danny DeVito of large galaxies. I get that. So fair's fair, you guys can have Andromeda. And I will point out here, this little green spot here is the Tarantula Nebula. And that's a really cool thing to see in our nearby galaxy, is that we can image the nebulas within another galaxy somewhere else. And if you just take an image with your camera, it shifts into the green. I don't know why it's green, because we know it's hydrogen, and we know if we process it correctly, it's actually quite red and beautiful. This is taken with the 11-inch RASA. And the good thing about Tarantula as well down the south is that it's circumpolar, so it's always at the pole. And you find this, especially on our astronomy forums and things like that, whenever you're having trouble with something else, having trouble with Orion or having trouble with Carina, or everyone's backup is always Tarantula. Tarantula's always there in the sky. But we need to go deeper. So around the LMC, around the Large Magellanic Cloud, there's a whole bunch of little nebulas, not just Tarantula. This is an example of the Dragon's Head Nebula. Obviously, a lot of star formation going on, old stars, new stars, and I don't know what's going on here. There's a star that's shedding stuff. It's just really, really fascinating. Not a common one, this one, but one that I really like. So I have a bone to pick with New York City. Do you guys know what this one's called? It's the Statue of Liberty Nebula. But you guys can't see it. So we've got an object that's named after one of your most iconic statues. It's like if I call the Heart and Soul Nebula the Great Barrier Reef Nebula. So I'm thinking about it. This is taken with a Celestron 9 1/4. But I think it should be called the Breakfast Club Nebula. Because I don't know about you, but this is uncanny. We've got the part of the hair, we've got the glove, we've got the lapel, we've got the belt, we've got the flick of the coat. It's uncanny. So I propose that if we rename this the Breakfast Club Nebula, then I won't rename the Heart and Soul Nebula the Great Barrier Reef Nebula. Now, over east, because we have this fantastic clear view out over the ocean, there's an effect that you normally only see from photos like Don Pettit's, where you're taking photos from the International Space Station, and you can see that thin sliver of atmosphere. And you can see that that thin sliver is glowing green. And that is our glow. That's the glow of our planet. And it's very hard to capture unless you have a super deep sky. And I'm lucky because I can see the horizon as well going out over east. So it's a very special phenomenon you can get with these wide-field Milky Way shots. So I want to talk quickly about the dark nebulas that we can see out there. This is Corona Australis, which I like because it's named after my country, the dark molecular cloud. There's so much going on in this nebula. It's big, it doesn't even fit into this frame, which is taken with, let me see, what's this one taken with? The RASA 11-inch, 30-second exposures, under an hour. So I've knocked this image out under an hour, which is what the RASAs are good for. And you can see up here, we sometimes call this guy Yoda. So that's Yoda's walking stick. He's holding a little walking stick there at his two eyes. And Australia literally means southern place. So here's a little map I found of the celestial sphere just to give you an idea of where everything is. You guys can see all your northern stuff up here near the pole. Both of us can see Orion because it's near the equator there, the celestial equator. And they didn't actually have much stuff to put down here. So whoever did this map is probably from the northern hemisphere. But I thought that would give you some perspective anyway. This gives you an idea of how much stuff is just in that dense region. It's just nebulas galore. So when you guys, I think you guys call it the galaxy season coming up, and for us it just goes from nebula season to more nebulous season. It's pretty mental. And the next slide is Rho Ophiuchus. You guys see this one, but I think it's a bit lower on the horizon for you guys. So this is pretty easy to take photos of. This is just piggybacked, so not using a telescope, just a Canon 200mm lens, 30-second exposures. I think this one is tracking, but it's not guiding, so pretty simple. But let's go a bit deeper. So you can see same area, just in quite a bit. So that's taken with the Hyperstar and the Celestron 9¼ Edge HD. And notice how I am, throughout this presentation, I'm changing focal lengths. And often we get into the trap of buying a setup and just like adding so much stuff onto a setup. You get focuses and you get rotators and you get all this stuff. But that actually makes it hard to change, chop and change. And what I like to do is I change telescopes, I change cameras, I change focal lengths, use reducers, don't use reducers. You get much more diversity in your images. And even though I'm taking an image of the same region, it's like a completely different photo with a completely different kind of feel to it. And sometimes I don't use telescopes at all. This is the Coalsack Nebula, which is the head of the emu in Aboriginal culture. And this is my incredibly urban situation. I'm up against fences, there's a street light up here somewhere, and I've got palm trees in the backyard. Basically, I can't see the pole. All I can see is straight up and across over the neighbour's fence. But that gives you an idea of the kind of urban situation I have, even though I'm in hippie paradise Byron Bay. But it also means that I have a time pressure. So when I'm imaging, I really love the F2 imaging, and it's why I've done so many videos on RASA, why I was so quick to take up Hyperstar in the first place. I don't want to spend like the whole 12 hours overnight doing astronomy. I want to knock out an image in a few hours and go to bed because I have kids who are going to jump on me at 6 o'clock in the morning. This is not one of mine. This is by Corey Schmitz from South Africa, I believe. This is called the Dark Doodad, which is a very imaginative name for a dark molecular cloud. But again, I just wanted to show you that all of those dust lanes in and around the core of the Milky Way are super populated with all of these dark nebulas, and they can be just as fun to take photographs of as the big bright nebulas as well. So we get on to my girlfriend, Karina. I really love this photo. It's taken in the Hubble palette, but I didn't push the green as you sometimes naturally want to do in the Hubble palette. This is taken with the 11-inch RASA, and again, it's a photo I've just knocked out over one night, so one session. Now, to give you an idea of scale, Orion is about 1.5 times bigger than the Moon, and Carina is 4 times bigger than the Moon. And that's just the core sort of area as well. This stretches out way past the frame, and you can see that it's stretching out way past the frame here as well on the 11-inch. And this is just taken with 60-second exposures as well. I find with the RASA, I love to push it, so I love to do like 5-10-minute exposures on the RASA just to get some insane, faint stuff. But I find that blows out the stars, especially when you're in a region like this or a dense region of the Milky Way. All the stars tend to get really fat, so I tend to stick to 30 to 60 seconds. So this is the same area on the RASA 8, the new RASA 8. This has been such a great scope to get a hold of and play with, and you can see it still doesn't fit the whole of Carina, and this is at 400 millimeters. So if they want to fit in the whole of this object, they actually need to, I don't know, do a RASA 6-inch or RASA 4-inch, Nexstar 4-inch RASA. I don't know. It's a huge target, and I really love it. And I should say the reason I take okay photos is because I have this stuff which is just so bright, and I'm using gear like the RASAs. There's really no way I can go wrong. You could be doing this unguided if you wanted to. I tend to guide and dither and all that as well, but this can be unguided. It's pretty easy. The gear and the targets are doing all the heavy lifting for me. This is Carina in natural colour, taken with the 11-inch, and you can obviously tell a natural colour image because you've got the blue stars and the orange stars. They all kind of get a bit weird when you're doing the narrowband stuff. But if you're closer to a city, narrowband is really your only option, which is why it's good to see that the RASA 8 will work with the narrowband filter draw system from Star Arizona. And I can see that particular setup has been hugely popular already. So it's an option. You don't have to have dark skies like I do to take images like this. This image could have been taken, not this image, but the last narrowband one could have been taken from the middle of Sydney or New York. So we need to go deeper. This is Carina not taken with the RASA. This is Carina taken with the 9 1/4. So we're zooming in to the region here. And there's so much to look at. Even in this one target, it's just filled with different stuff. And so I've tried to annotate it to give you an idea of some of these things, because some of these areas are famous Hubble images as well. We've got the Dusty Mountains, the Treasure Chest, the Keyhole, Ida Car, and this one is a famous Hubble photo. That one's a famous Hubble photo. But I think my favourite Hubble photo from this region is God's middle finger. And that is a Bok globule as well, which was named after Bart Bok. Just a fantastic section. Now, in that same area, Ida Car itself is a fascinating star. It's a candidate like Betelgeuse for going supernova. They don't really know when it's going to go supernova. They just suspect, based on its age and the evolution of stars, that it should be due sometime soon. And in the 1800s, do I have the year here? 1843, it became the brightest star in the sky. So that was an event that was witnessed all around the southern hemisphere. And it's this flaring that happens. The star shed a bunch of stellar material and flared up and became the brightest star in the sky. And we can still see the remnants of that here. But that sort of a shot, I had to find one online because I haven't done this myself. It's on my bucket list. This is the sort of shot that you'd take the same way you do planetary, the same way if you were taking a photo of Jupiter or Mars. You'd be doing video imaging on this. So you'd want a really long focal length and try and find that star and then be taking video to stack the video. This is taken with a C14 Edge HD and an ASI 224 MC and taken by a Brazilian guy called Ivani Soares. He used a 1.5-minute video. And what's also special about this is that we now know it's going to be gone in 10 years. It would be really interesting to see someone animate this or take photos of this over the next 10 years and stitch them together in an animation, because we're seeing the last death throes of a star before it goes supernova. And there's some argument, of course, as to if it goes supernova, will it have an effect on life here? The naysayers say it will wipe out our ozone layer and kill us all. But it would probably just look really cool and really cool to photograph, and I can't wait. This is another beautiful region of space, the Fighting Dragons of Ara. And this is also in the HST palette, so the Hubble Space Telescope palette, taken with the Celestron RASA in 60-second exposures. It's about half the size of Carina, but still twice as big as the Moon. So it's bigger than Orion still, but not quite as bright as Orion. So a massive, massive area, but we need to go deeper because I'm changing focal lengths again. And that's the same region taken in true color. And you can see how different these photos look. They're the same thing, basically just different focal lengths and different color treatments, one in one in true color and one in the Hubble Space Telescope. So a little closer up. We have some famous galaxies. There is the Sculptor galaxy there. I find galaxy work really hard, and I'm not a galaxy guy, as it were. But when you're taking photos of galaxies, you of course want to take the hydrogen alpha and lay that over your RGB, so you can see those beautiful red jewels popping out of your image, and you can get all that beautiful nebulosity coming through. We have this other weird galaxy called Centaurus A, or sometimes called the Hamburger galaxy. And we're still arguing over what it is. It's really weird looking. It's not like any other galaxy. It's definitely not the Arnold Schwarzenegger, and it's not the Danny DeVito even. It's just super weird. And it's really close. And it's close enough that we can study it quite well. And it has very strong radio emissions. But it might be, because it is this close, that we find it weird. Because unlike the other galaxies, which are quite distant, we've got a very good view of this one. And because of that, we can't figure out whether it's elliptical or regular or what it is. And this was discovered in Sydney in the 1800s by a Scotsman. But the only thing you'd discover in Parramatta these days is probably a hypodermic needle or a parking ticket. This is the Milky Way core. It's super dense. You guys can see this too, and I see images of M8, the Lagoon Nebula, and the Trifid coming from here. But again, just a little lower on the horizon for you, and it's just straight up for us, which makes it really easy to take photographs. And you can see the dense star field is just something to behold. This is Saturn running through here, M8 and M20. And it's when you're imaging like this and you put your guide camera on, there is no trouble picking a guide star. Your little guide camera is just full of stars. It's really quite something. This was taken with 30-second photos and a 200mm lens, so it's not even through a telescope. It's just riding piggyback on the CGX. Now, this is our South Celestial Pole. Do you notice anything different about our celestial pole compared to yours? The pole star. You guys have a bright star right in the middle, which makes it super easy for you guys to align your telescopes when you're at a star party. And we've got nothing. And I told you before how useless constellations are. When you're out, good luck finding octans. It's invisible. So we go out to star parties and we use all sorts of weird and wonderful methods. Of course, we've got our compasses out and we're trying to work out the offset, and we've got sticks in the ground to see the shadow at a particular time of day and work that out. But if you go to a star party in the southern hemisphere, everyone's screwing up on the first night, and by the second night they've got their polar alignment worked out and everything's running fine. But I do truly recommend the Celestron All-Star Polar Align method. That's always worked for me very well. So this is taken in Western Australia. You can see the large and small Magellanic clouds as little fluffy blurs there. And this is taken at the DSA-1 tracking station. I was lucky enough to be commissioned by the European Space Agency to go do some photography of their dish over there. And we've got a few good big dishes in Australia. And have you guys seen the movie The Dish? Know of it? If you haven't seen it, it's about the Apollo mission, and it's about the fact that when Neil Armstrong was stepping onto the moon, those live images were not coming to you direct from NASA, they were coming to you direct from Parkes, where the big dish is in Australia. Because any space agency needs to be in contact with their satellites all the time, there has to be at least 3 dishes on each side of the planet so that they can remain in contact. So Australia has a bunch of these dishes for various space agencies so we can remain in contact. And as Neil Armstrong came out of the module, our dish was at its limit. It was literally standing up on its side, and they just managed to make contact. And it's a very good movie. You should see it if you can. It's called The Dish. There's a whole bunch of moon's conspiracy theories about the tapes from that mission, and that they'd been doctored through Australia, and that we were sending computer graphics through, and it was all fake and all that. But a guy called John Sarkisian from the CSIRO won the Order of Australia, which is a medal from the Queen, for doing all the research to try and find where these missing tapes are from this mission. And they never found the missing tapes, but it could be, they think they've either been destroyed or it's at an ex-employee's house and they can't get a warrant to go get into this guy's house. So the moon conspiracy theorists obviously take that one to town. Speaking of the moon, I'm sort of known for moon photography, which is ironic because I kind of don't like the moon most of the time because I'm a deep space imager. But I have taken a few nice transit photos. Obviously, you guys can see this here too, and you guys can do this too. But when I first got into astronomy, taking a transit photo was the furthest thing from my mind. I'd read about it in magazines, astronomy magazines and whatnot, but I thought, that's crazy. How could you possibly do this? It was like some sort of dark art. But then after a while, I got comfortable with using my gear and I tried it, and it worked. And I just couldn't believe it. So I have made videos about this and how you can do it as well. And it's really nice when people come up to me and they show me their transit photos and that I'd help them do that. This is one that is on exhibit this year at the Hudson River Gallery. So I'm actually exhibiting in New York, which is super weird as well. And Tim Peake was on the space station at that time. But this is probably my most famous transit image. This is the one that went viral and when people started to notice me a bit more and when I climbed the ranks of Google for the search Dylan O'Donnell. And it got picked up by mainstream media and it got retweeted by the International Space Station. Chris Hadfield was getting asked questions about it in interviews and stuff like that. It was really amazing. But I don't know why, I don't really know what makes something go viral, right? We don't expect to go viral and we don't know why it happens. I suspect it's something to do with the way the space station is positioned near the craters and near the Terminator, and also that I process the image in color as well. We're used to seeing very monochromatic images of the moon, but the moon has a very natural color that you can bring out quite easily just by pushing your processing a little more. So here is the moon at sunset for Stonehenge and New York. So you can see something weird. They look backwards, don't they? This is not the way we normally display them in classical literature and paintings and things like that. The moon normally is pictured like that. And that's not something I've just noticed. It's something that The Simpsons do as well. So it's always been a mystery where Springfield is, but astronomers have studied The Simpsons and we've worked out that it's in New Zealand. So all this time you guys have been saying that my photos of Orion and my photos of the moon are upside down. Turns out you guys have been upside down this whole time. This is a pretty stark contrast. This is the difference between the light pollution in America and Australia. You can see if you're in the middle of Australia, it's dry, so the skies are clear pretty much all the time, and there's no light not just near you, but for miles and miles. I'm lucky enough to live on the easternmost tip, so I'm about here, so I'm well away from the cities. Any light pollution in the town is you walk out the back door and out the fence and across the street and you're out of the light pollution, basically. It's very easy to photograph. This is the middle that I was talking about. So in the middle of Australia, we have Uluru, which is a big rock that we don't really understand. And it's a beautiful thing to photograph. Now, I was looking at traveling there to do photography like this, and I saw a Facebook ad that said that I could go on a tour there for $3,000. I thought, oh, that was interesting. And I clicked in and I read the fine print and it said, does not include flights. So I'm thinking, well, what's the $3,000 for? And I did some more research and found out that the rooms are only like $100 a night. So you don't need to spend $3,000 on a tour to get an image like this. You just go and get the $100 a night room, wait till it's dark, and walk outside. Like, it seems like a bit of a scam. Anyway, this is Uluru. Also near Uluru, we have an American military base where we help America and New Zealand and Canada and England spy on all of your emails and store everything so that we are part of the Five Eyes spying and data collection. And we don't know when America comes in and out. They can just go and leave whenever they like. It's a very interesting part of the world. Also, you can get meteorites there. I've spoken to Jeff Notkin about this, the meteorite expert. If you walk out into the desert with a magnet, you will find meteorites. When meteorites fall by the coast or in wet areas, they rust and they'll disappear after a while. But here in the middle of Australia, not only will you go and find dark skies, if you just walk around with a magnet cane or a large magnet, you will find meteorites. Now, there are other things to contend with in Australia when doing astrophotography. This is a black and white bandy snake that I almost stepped on while going out to get a Milky Way shot. There's a green tree frog that I found on my Celestron tripod as I came out to check the imaging run. There's a python that was in my tool shed as I went to get a screwdriver. I've also had pythons on the fence next to me while I'm imaging that you just don't see until you turn on the light after the night's imaging. But they're mostly harmless, and they're harmless enough that I will trust my young boy, Zenon here. This is my son holding an adult python with a broken arm. That's a pretty Australian photo, don't you think? But the other day I came out to my rasa and found that a giant bat had defecated all over the mirror. They eat these fruit berries and then they crap them out, and so a lot of people ask me how I cleaned it. And I cleaned it very, very carefully because if you scrape, you could have scratched the glass. And there's that same snake, which I said was harmless on the last slide, eating one of those fruit bats, which I don't mind at all. Now, I am mostly into pretty pictures, but I am doing an astronomy degree, and I do dabble in the sciencey side of things. So every night there is a list of objects that have been discovered, and this is happening right now, and this is a live website. I can give you the link if you need it. It's on the video about this. But the Minor Planet Center shows us the things that we've discovered moving in the sky each night. And any given night, there might be 20 or 30 things which are brand new to us, brand new to science. We've never seen them before. And it's hard. This list was hard to pass. It was just a list of numbers. So I thought, I'll take the numbers and I'll write some code and I'll make it so that we can actually see what's going on. Because I wanted to see if there was any of these things I could do follow-up observations for. But when I did it, I found something really interesting. And that was this huge bias in the data. I mean, the first bias is the fact that it's just a big strip, right? So that's a time of night. That's a time when they turn on the telescopes, do their survey work, and then turn them off for the night. That's one bit of bias. The other bias, of course, is that we have things clustered here around the equator. Huge cluster, a bunch up north, and a few little observations down south. So what's causing this bias in the data? And the bias is caused mostly because the two primary surveys now are Pan-STARRS and Catalina. So they're doing most of the heavy lifting for this, and you can see where they're located here. I should show you as well the locations here. We have, this is obviously happening around those survey locations in Hawaii and America. That white dot there is where I am, so I could tell if I could follow up on any of these. And the yellow bar here is where Bruce Willis is at any time, in case we need him to deflect a meteorite. And that's funny, right? But if you look at this graph, Armageddon the movie came out here. And funding, Congress suddenly said, we need funding to find out where all of this stuff is, because they became suddenly concerned about the impact of asteroids over 1,000 meters or 1 kilometer. They reckon they found about 80%, which doesn't comfort me too much. The funding continues, but unfortunately my country just dropped out, and for political reasons, politicians want to divert money to other things. I think our government's spending $250 million on advertising themselves this year. So that's funding that was pulled from CSIRO, our space agency, our science organisation, and funding for that blind spot. Because this is a blind spot. In the southern hemisphere, there is a gap in the data that you can see there where there could be things happening. There could be asteroids that we haven't discovered. There could be potentially hazardous asteroids that would change life on this planet that we simply can't see. And that's an opportunity. It's an opportunity for me. It's an opportunity for any astronomer in the southern hemisphere, A friend of mine, Terry Lovejoy, has a Celestron 14 with Hyperstar, and he discovers comets from his backyard. He's discovered 5 or 6 now. And the reason he can discover them is because he doesn't have to compete with the big surveys, because he is exploiting that gap in the data. And the other thing to note is that if you discover a comet, it gets named, you get your last name after it. So it's Comet O'Donnell or Comet whatever. And it's there in perpetuity for history. Every time this comet comes back, long or short, it's named after you. Now, I did propose that you should, what we could do as astronomers is go to companies like McDonald's or Coke and convince them to fund an observatory, because if they found a comet and it was called the McDonald's Observatory, they would get the credit, and then for history, they would be called, you know, Comet McDonald's or whatever coming through. And I had people who were absolutely horrified at this suggestion, and a lot of professional colleagues just said that's disgusting. And I sort of said, well, I don't really care who's paying for it. If you can trick a company into paying for astronomy gear and searching for the missing 20% of asteroids which may or may not cause extinction on this planet, that's fine by me. I don't really care what the asteroid is called at all. So anyway, my name is Dylan O'Donnell. You can find me on Instagram. You can find my videos on YouTube. I run a festival in the Southern Hemisphere called Star Stuff, where you can come down and see the southern night sky and hear lots of cool speakers as well. I'll take some questions, but remember, everything is meaningless and we're all going to die. I think, is there a format for questions? Do you just sing out, or? You've got a question up the back here. So what I tend to do is a trick with one-shot color, but then I use HA as the detail layer, so the luminance layer. So I tend to use HA RGB. You just get way more detail that way, yeah. That's the way I tend to do all my true color images. Often in the same night, yeah, because it's imaging at f2, so you just swap the camera. I'll use the same setup, take the hydrogen alpha narrowband mono camera off and put the RGB camera on, and that works great. It's a real kind of shortcut, yeah. Any other questions? Yep.
Obviously, there's this real northern hemisphere bias like you were talking about with an SEA catalog and how that came about. And you said that you just look for NGC codes in the southern hemisphere. Have you ever thought about making just a southern hemisphere catalog?
That would be cool, yeah. We could have a catalog that excludes all of you guys and just have our stuff in it. I like that idea.
Comparable objects, the faint fuzzies that you don't need heavy gear to find.
The O catalog. I am so into that idea. No, I think that's an excellent idea. Thank you for that. I think there's another question up there somewhere. No? Are we done for questions? I think that's it. Thank you very much. Oh, one more. I cannot image from New York. I don't know how you guys do it. Thank you very much, guys.
Hey, thank you very much. Thank you very much, Dylan. Great job. Great job. Thanks.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
It's
great to be here. Thank you. Wow, there are a lot of you. What a great conference.
Friday, I was the launch chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together, and putting your own vision on that and showing how you see the sky.
Hi, my name is Jeff Norwood. I'm the owner of Camera Concepts and Telescope Solutions. We're based in Long Island, New York, and we are, I'm proud to say, one of the supermarket vendors of telescopery. We sell everything and everything, from accessories to screws and bolts to things you need at star parties, all the way up to Takahashi's and you name it. All the rest of that. So at our booth here, we've been coming here to NEAF for over 20 years. We basically bring the entire store with us. So we've got lots of goodies. And of course, everything's on sale, great deals. Our website is www.cameraconcepts.com. Please visit us. We support what we sell. We've got experts in the field on staff to help you with astrophotography, all your visual aids that you might need. So thanks a lot, and bye.
Hi, I'm Kelly Beatty from Sky and Telescope. I'm a senior editor on the staff. I've been on the staff of Sky and Telescope since 1974, hard to believe. But I'm still having fun, and why wouldn't I? We're a very important part of the amateur astronomy community, just as NEAF has become a kind of essential go-to place each year for many thousands of people in the amateur community. We're here, we're one of the co-sponsors of NEAF, and we are dedicated to being a major part of that. You know, people think of us as just Sky and Telescope magazine. We're actually much broader than that in a couple of respects. One thing is we do a lot of outreach. We provide a lot of materials for amateur clubs across the country when they need materials to distribute at their star parties and such. And we also do some products that are maybe not what you'd expect from a magazine. I've got a couple here. We have a whole line of globes that we sell. They're really great. This one, for example, this black beauty is our celestial globe, which shows all the stars in the sky down to 5th magnitude. And then this is our new one, just about to be produced. It's a globe of the Earth, obviously, but it shows all total solar eclipse paths until the year 2100. So if you're the kind of person who likes to plan ahead, this is just the globe for you. You'll know where to be in 2024 and beyond. The other thing we do a lot of is tours. Speaking of those eclipses, we've actually got a whole bunch of tours that we do all over the world. We just had a tour finish in Finland to go see the auroras. It was very successful. This summer we have a tour of Chile coming up for a total solar eclipse. We've got an observing tour planned for Australia that is just going to be killer. So for all these reasons, Sky and Telescope sort of considers itself the essential guide to astronomy. And again, we've been at this for 75 years, so we really have a good handle on the amateur community. We're from the amateur community. We'll always be a part of it. And we are so grateful to the organizers of NEAF, Ed Seaman and the rest of the crew here for welcoming us every year and being such gracious hosts in this amazing setting where the sky is really the limit. So thanks very much for the opportunity to chat, and we'll see you here next year.
Hello there, I'm Lonnie Ouija with Celestron, and we're here live today at NEAF, and I thought I'd show you one of our new products. So what you're looking at is a brand new Roe Ackerman design. We call it RASA. This is an 8-inch f2.0 imaging system. Now, one thing you'll notice about this, if you look at where we place the camera is designed to go on the front of the telescope. What we've done is we've taken a standard SMIT design and turned it into a RASA design, and that means the light goes through the corrector plate, it hits a primary mirror in the back, it's reflected back up on the camera, and we get very fast wide field images. If you notice the camera we're using, it fits inside the objective so we don't block any of the light. This has been a hugely popular product for us. We're unique in this design. If you're interested in wide field imaging, if you're interested in the sky surveys, if you're just interested in a good, fast way to get started with astronomy, the Roe Ackerman is new. If you notice, we also have our new focuser on the back. This is something that's nice to have when you're doing astronomy and astro imaging. This will have steps that you'll be able to do the micro focusing needed to control a fast imaging system like this. We're very happy to have it here at NEAF, and come on by and take a look.
Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we've got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us.
We're live here at the NEAF conference in Suffern, New York, and we're from Lowell Observatory. And Lowell Observatory this year is a great year because we're celebrating our 125th anniversary. So 125 years of great discoveries, and that's really the legacy of Lowell. We've been doing important research from the discovery of Pluto to VM Slipher's recessional velocity work to current research using our Discovery Channel telescope to discover planets around other stars and a lot of other great work. So we're doing a lot of great things, and it's also a great place to visit.
And we're doing all kinds of neat things this summer to commemorate our 125th anniversary. So we have coming soon the opening of our Giovanni Open Deck Observatory, which is going to feature 6 modern telescopes fully dedicated to public observing. A great suite of instruments there and some nice interpretive locations to look at and learn more about the telescopes and astronomy. And then of course this summer we're also celebrating the lunar legacy for Flagstaff as we approach the 50th anniversary of the lunar landing.
And it really is a great time to celebrate the 125th of Lowell and the 50th of the first moon landing, and all the astronauts who walked on the moon trained in northern Arizona. And so we have a community-wide celebration at Lowell Observatory and other science centers. Even our businesses are getting into it, creating specialty drinks like the Earthrise cocktail and a special moon pie and all sorts of other great desserts. So it's a really great time from now through the end of 2019. We're doing this Lunar Legacy celebration, plus all the stuff we normally do at Lowell. And we're also opening this new Open Deck Observatory that Danielle mentioned that's going to change how we do astronomy outreach, because we have big 32-foot-long telescope to look through, plus this suite of state-of-the-art telescopes that our visitors can really see what it's like that real scientists do, and also just the wonder of looking through an eyepiece and gazing in awe at the universe. It's just something that we as humans, it really captures our spirit. So there's a lot of great stuff like that to do at Lowell.
And speaking about looking through the eyepiece, there's nothing like looking through the 24-inch Alvin Clark telescope, refractor built in 1996. So it's 123 years old this year, and we just restored it a few years ago. It's gorgeous looking through, and you can do that on Mars Hill in Flagstaff. So lots going on this year.
Yeah.
And we're here at NEAF in Suffern, New York, and looking forward to chatting with more people about Lowell's legacy over 125 years and all the neat things that are happening for our next 125.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
It's great to be here. Thank you. Wow, there are a lot of you.
What a great conference.
Friday, I was promoted chief engineer, and that means that I'm really busy with the mission.
No one has ever seen before.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures, but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together and putting your own vision on that and showing how you see the sky. My name is Grant Regan and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together and putting your own vision on that and showing how you see the sky.
Hello there, I'm Lonnie Ouija with Celestron, and we're here live today at NEAF, and I thought I'd show you one of our new products. So what you're looking at is a brand new Roe Ackerman design. We call it ROSA. This is an 8-inch f2.0 imaging system. Now, one thing you'll notice about this, if you look at where we place the camera is designed to go on the front of the telescope. What we've done is we've taken a standard design and turn it into a ROSA design, and that means the light goes through the corrector plate, it hits a primary mirror in the back, it's reflected back up on the camera, and we get very fast wide field images. If you notice the camera we're using, it fits inside the objective so we don't block any of the light, This has been a hugely popular product for us. We're unique in this design. If you're interested in wide field imaging, if you're interested in the sky surveys, if you're just interested in a good, fast way to get started with astronomy, the Roe Ackerman is new. If you notice, we also have our new focuser on the back. This is something that's nice to have when you're doing astronomy and astro imaging. This will have steps that you'll be able to do the micro focusing needed to control a fast imaging system like this. We're very happy to have it here at NEAF. And come on by and take a look.
Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us.
Hi, my name is Jeff Norwood. I'm the owner of Camera Concepts and Telescope Solutions. We're based in Long Island, New York, and we are, I'm proud to say, one of the supermarket vendors of telescopery. We sell everything and everything, from accessories to screws and bolts to things you need at star parties, all the way up to Takahashi's and you name it, all the rest of that. So at our booth here, we've been coming here to NEAF for over 20 years. We basically bring the entire store with us. So we've got lots of goodies. And of course, everything's on sale, great deals. Our website is www.cameraconcepts.com. Please visit us. We support what we sell. We've got experts in the field on staff to help you with astrophotography or all your visual aids that you might need. So thanks a lot, and bye.
We're live here at the NEAF conference in Suffern, New York, and we're from Lowell Observatory. And Lowell Observatory this year is a great year because we're celebrating our 125th anniversary. So 125 years of great discoveries, and that's really the legacy of Lowell. We've been doing important research from the discovery of Pluto to VM Slipher's recessional velocity work to current research using our Discovery Channel telescope to discover planets around other stars and a lot of other great work. So we're doing a lot of great things, and it's also a great place to visit.
And we're doing all kinds of neat things this summer to commemorate our 125th anniversary. So we have coming soon the opening of our Giovanni Open Deck Observatory, which is going to feature 6 modern telescopes fully dedicated to public observing. A great suite of instruments there and some nice interpretive locations to look at and learn more about the telescopes and astronomy. And then of course this summer we're also celebrating the lunar legacy for Flagstaff as we approach the 50th anniversary of the lunar landing.
And it really is a great time to celebrate the 125th of Lowell and the 50th of the first moon landing, and all the astronauts who walked on the moon trained in northern Arizona. And so we have a community-wide celebration at Lowell Observatory and other science centers. Even our businesses are getting into it, creating specialty drinks like the Earthrise cocktail and a special moon pie and all sorts of other great desserts. So it's a really great time from now through the end of 2019. We're doing this Lunar Legacy celebration, plus all the stuff we normally do at Lowell. And we're also opening this new Open Deck Observatory that Danielle mentioned that's going to change how we do astronomy outreach, because we have big 32-foot-long telescope to look through, plus this suite of state-of-the-art telescopes that our visitors can really see what it's like that real scientists do, and also just the wonder of looking through an eyepiece and gazing in awe at the universe. It's just something that we as humans, it really captures our spirit. So there's a lot of great stuff like that to do at Lowell.
And speaking about looking through the eyepiece, there's nothing like looking through the 24-inch Alvin Clark telescope, refractor built in 1896. So it's 123 years old this year, and we just restored it a few years ago. It's gorgeous looking through, and you can do that on Mars Hill in Flagstaff. So lots going on this year.
Yeah.
And we're here at NEAF in Suffern, New York, and looking forward to chatting with more people about Lowell's legacy over 125 years and all the neat things that are happening for our next 125.
Hi, I'm Kelly Beatty from Sky and Telescope. I'm a senior editor on the staff. I've been on the staff of Sky and Telescope since 1974, hard to believe. But I'm still having fun, and why wouldn't I? We're a very important part of the amateur astronomy community, just as NEAF has become a kind of essential go-to place each year for many thousands of people in the amateur community. We're here, we're one of the co-sponsors of NEAF, and we are dedicated to being a major part of that. You know, people think of us as just Sky and Telescope magazine. We're actually much broader than that in a couple of respects. One thing is we do a lot of outreach. We provide a lot of materials for amateur clubs across the country when they need materials to distribute at their star parties and such. And we also do some products that are maybe not what you'd expect from a magazine. I've got a couple here. We have a whole line of globes that we sell. They're really great. This one, for example, this black beauty is our celestial globe, which shows all the stars in the sky down to 5th magnitude. And then this is our new one, just about to be produced. It's a globe of the Earth, obviously, but it shows all total solar eclipse paths until the year 2100. So if you're the kind of person who likes to plan ahead, this is just the globe for you. You'll know where to be in 2024 and beyond. The other thing we do a lot of is tours. Speaking of those eclipses, we've actually got a whole bunch of tours that we do all over the world. We just had a tour finish in Finland to go see the auroras. It was very successful. This summer we have a tour of Chile coming up for a total solar eclipse. We've got an observing tour planned for Australia that is just going to be killer. So for all these reasons, Sky and Telescope sort of considers itself the essential guide to astronomy. And again, we've been at this for 75 years, so we really have a good handle on the amateur community. We're from the amateur community. We'll always be a part of it. And we are so grateful to the organizers of NEAF, Ed Seaman and the rest of the crew here for welcoming us every year and being such gracious hosts in this amazing setting where the sky is really the limit. So thanks very much for the opportunity to chat, and we'll see you here next year.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together and putting your own vision on that and showing how you see the sky.
Today my guest on Cosmic Perspective Radio from the Northeast Astro Forum in Suffern, New York is Lowell Observatory historian Kevin Schindler. Kevin, thanks for joining us on Cosmic Perspective Radio today.
Hey, great to be here. Thanks.
The Lowell Observatory is best known to most of us through Percival Lowell's quest for Planet X and of course later Clyde Tombaugh discovering Pluto. But the observatory and some areas in northern Arizona have played some very big roles in the Apollo program and landing men on the moon.
Yeah, it is. It's kind of an unknown story unless you go to Flagstaff, and even there, it's amazing how many locals aren't aware of it because it's been 50 years. But when Kennedy made that declaration, we're going to the moon, boy, we had to get rockets ready and figure out how to fly in space. We had been in space for 15 minutes with Alan Shepard's flight, and now we're going to go to the moon. So there was so much effort in getting more astronauts, developing the rockets, developing techniques to dock rockets and so on. But then there were scientists like Gene Shoemaker, and Gene Shoemaker was a geologist, and he started the branch of astrogeology, which was designed to help prepare for moon missions. And he said, what's the point of going, we're going to try to beat the Russians. We understand that. Plant the flag, come back safely and everything, but what a lost opportunity if we don't do science. And so he said, we should do science. We should train the astronauts to be geologists. So when they get there, every second, is expensive to go to the moon. So we should make the most of their time, make sure they're fully trained in being geologists so they can identify rocks and be able to identify their landing sites and read aerial maps and photographs so they can pinpoint their location and that sort of thing. And so the second group of astronauts in the next 9, which included Neil Armstrong, Jim Lovell, and Frank Borman and others, NASA did kind of a test. Bring them out to Flagstaff, Arizona, where Gene Shoemaker's crew was, and let's just do a test to see if it's worthwhile training them. And so they went to Meteor Crater, the world's best preserved impact crater, and that's what they expected to find on the moon, impact craters. And so they saw a real one, and then they went to Lowell Observatory, where I work, and at Lowell we were mapping the moon, because like you go to a foreign country, if you don't have a map, you're not going to get anywhere. If you go to a foreign world, you don't want to land in the side of a crater or something like that. So, we had some decent pictures of the moon, but not great.
Nothing detailed at that point?
Not detailed enough. Mm-hmm. And the pictures weren't good enough. There weren't spacecraft orbiting the moon yet to get really close pictures. So Gerard Kuiper, an astronomer, had this idea, let's get the best pictures of the moon we have and go to a telescope and look through the telescope at the moon and wait for those moments of exquisite seeing. You look for a while, and every once in a while, everything is just crystal clear, and record that quick, make a sketch of it, and keep doing that over and over till we can have enough detail to create these maps. And so it was an amazing project. It was scientists working with scientific illustrators. They had airbrushes to sketch these details all by hand.
All by hand?
All by hand. And they made these, they're really pieces of art, what they created. And so the astronauts went to Lowell to learn how to see these features on maps, how to identify them, because they were going to be taking the maps to the moon and identifying their location and such. And so then they went at nighttime. Some of them stayed at Lowell, some of them went to the U.S. Naval Observatory's Flagstaff Station, some went to the University of Northern Arizona University, all of which had telescopes. And so they split up and through those telescopes looked at the moon and saw the moon close up for the first time. And so in one day, they saw a real impact crater, they saw how these features were depicted on maps on the moon, and then looked at the moon through the telescope. And it was really successful. NASA realized this is going to be worthwhile training. And so in the ensuing years, all the Apollo astronauts went to northern Arizona. They went back to Meteor Crater, but they also went to volcanic fields in the area, Sunset Crater, a famous one. And they went to the Grand Canyon. And the Grand Canyon, they didn't expect to find a Grand Canyon on the moon. And the rocks aren't sedimentary like a lot of the Grand Canyon, but they realized the Grand Canyon, the geologists can learn about scale and looking across horizons and understanding how rocks are laid down. But also, another reason they went is you know, the astronauts were test pilots and fighter pilots later on. And in some cases, they were a little bit cynical maybe about doing science and picking up rocks. Picking up rocks wasn't going to beat the Russians. And so they had to be kind of convinced, if you're going to go there, we want you to pick up rocks. The geologists wanted to inspire them to want to learn to do geology. What more inspirational place for geology than the Grand Canyon? And so it's almost it's an embarrassment of riches. You know, from Flagstaff, Meteor Crater is 45 minutes in one direction, the Grand Canyon is an hour and a half in another. It became a central point for doing this training and learning geology. And, you know, it wasn't the only place they learned geology. The astronauts went to New Mexico and California and Hawaii and New Zealand, other places. But it was kind of one of the central points because the USGS was there, and they not only trained the astronauts, but they were developing instruments, the hammers and the tongs and the shovels and the spacesuits and the rovers. They were developing and testing those in the area. And so that seemed like a natural place. So it really was a center point. And in fact, at one point, as the astronauts were training in all these places, NASA said, you know, this is great, but we want even more. You know, we have the best preserved impact crater, but one of the first things the astronauts do when they get to the moon is going to be look out their little triangular window and describe the landscape, describe the craters and the valleys and mountains and whatever. And we have to have them trained so when they get to the moon, describing it as second nature. They're not umming and ahhing, and they use the terminology that the scientists agree with. And so NASA said, we want a field that looks just like the moon, an entire crater field. And so near Sunset Crater in Flagstaff, there's a large cinder field. It's just big flat. It was devoid of vegetation at the time. And that was a great place to create this man-made field.
They made their own lunar landscape.
They made their own lunar landscape. They got a picture from one of the lunar orbiters of an area of the Sea of Tranquility, and they plotted out every crater, and we're talking about a couple hundred, and they plotted them out, and they're all different sizes. And so they plotted them out. They dug holes of different depths. They put explosives of different amounts of charges, covered them back up, and then blew them up. And then did a series of these so they'd have sequential, you know, some that are older than others. And there's video of this. It's spectacular. You can get online and watch it, that they documented this. And they made a second field that was more than 400 craters. And you think about the time it took to plot those, to dig the holes. Initially, they dug them by hand, but then they got a backhoe. But still, you think about the time and the attention to detail to create that. That was just a small part of going to the moon. And it really gives you an idea of the magnitude of the effort to go to the moon and to do science and everything. So anyways, Flagstaff was this center point for all this stuff.
It seemed to be the perfect place.
It really was. So all the astronauts who went to the moon trained in Flagstaff and, you know, hiked in the Grand Canyon. Actually, it's a neat story. One of the astronauts who walked on the moon, the only astronaut on the moon that was a scientist was Jack Schmitt. Harrison Schmitt. He was a geologist, and he was working at the USGS in Flagstaff when he was chosen to be an astronaut. And so he helped train some of the other ones, but when it came time to go to the Grand Canyon, I mean, he's a geologist. He didn't need inspiration. He already knew the geology. So while the test pilots were in the Grand Canyon learning geology, the geologist was in the air learning how to be a pilot. So he's the only one that didn't train in the Grand Canyon.
That makes a lot of sense.
Yeah.
And I do recall way back when all this was happening that some of the astronauts were not really happy about being geologists or trained to be geologists.
That's right, and some of them were downright ornery about it. And then, you know, Schmitt was scheduled to be on Apollo 18, but then the program was cut, funding reasons. And so because of pressure from the scientific community, one of the pilots that was scheduled to be on 17, he got bumped for Jack Schmitt. And that created a certain amount of consternation, you know, that, okay, our guy is getting bumped for that. So, you know, there's certainly a little tension with it, but, you know, in hindsight, you know, I don't think there's any tension about it anymore. But, you know, they accepted Jack Schmitt, and they went to the moon, and he did a lot of great work. But, you know, you have some of these guys, like, there are stories about when they went to the Grand Canyon. Several of them, like Buzz Aldrin and Alan Bean, said, that's where I first really got it with geology, the scale and the magnitude of rocks. That's where it really sunk in. But there are still some others. Gene Cernan later remembered his biggest memory of the Grand Canyon was a rock throwing contest with one of the other astronauts, because he didn't really care about the geology quite so much.
I remember I had actually asked Gene Cernan about when he landed on the moon, like when nothing moves, like, how does that feel? And he says, that was no big deal. He says, but it was very hard to judge how far away everything was. He said it was much easier to judge it here, even though, he was in a big desert here. There were no other really landmarks other than what they were seeing at the time.
And that was a problem for Apollo 14 with Alan Shepard and Edgar Mitchell. And that was kind of an in-between mission. The early missions, Neil Armstrong and Buzz Aldrin, they walked around. And they walked, half mile or so. But for the later missions to really do exploration, you wanted to travel more. And they developed the rovers where they could travel a few miles. But Apollo 14, the rover wasn't ready yet. So they had a glorified golf cart, essentially. It was called the Modularized Equipment Transporter, the MET. And it was this big thing they had to drag behind them where they could, load rocks and equipment and such. And when they were dragging this, they were trying to get to a crater, but they couldn't tell how close they were because of that difficulty in doing that. And they got so tired and they were sweating, and they finally had to stop and turn around. And they came within not very far from the crater, but they just couldn't tell the distance. And so they didn't make it. But that was a good example of, it's a different environment. And they trained so well on Earth, but it's still not the same as being there. They trained to get used to the reduced gravity. There's only 1/6 gravity. They would go in water, in swimming pools, to move around, or have a harness attached to them to lift them up so the weight would be the same as on the moon. It's still not the same as being on the moon. And so you can do all the training you want, but then you still have to adjust.
Yeah, and I did talk to Ed Mitchell also about that mission, and I was amazed how far they walked and how far they climbed on that mission.
Yes.
But I didn't know about that they couldn't get to where they wanted to, not knowing how far away they were. I didn't realize.
And that cart they pulled, because the lunar surface is called the regolith, and it's just really powdery, because the moon has no atmosphere, and so over millions of years, little micrometeors, instead of burning up in the atmosphere like we have, that in the form of shooting stars, on the moon there's no atmosphere, so these things pulverize the surface, and over time makes this powdery. And so pulling that cart through that powdery surface, it got so difficult, sometimes they just lifted the cart and carried it, which kind of defeated the purpose of the whole thing.
You would think that, of course it's a different place. You would think that in the desert they would be able to simulate the same thing, but it was very different.
Yeah, and that powdery surface and the gravity, they trained for it, but it still was a lot more difficult, and not being able to tell exactly how far away the crater was, that really made a big difference.
Yeah. Well, it's so exciting that this is the 50th anniversary. It's exciting also that now we're going to go back to the moon again, and the president now says that we're going to go back and have men landing on the moon in 5 years or less.
We'll see. I hope that happens. As administrations come and go, plans like this come and go, but the exploration of space, it's something that gets to that human part of all of us, that feeling of wonder. Where you walk down the street and everybody's looking at their cell phone and staring at their phone, but somewhere along the way, we stop and look up and, think about our part in the cosmos and what's out there. And it's just that human part of us, that awe of the universe. And going into space, we're all explorers. And so when those 12 men walked on the moon, we all walked on the moon. And so for us to be able to go back to the moon and all of us explore, kids these days, the Apollo missions, it doesn't compute. It's so long ago. It's like when the Apollo missions happened, it had been 50 years since World War I. That was a lifetime ago for younger people. So, for us today, to be able to have kids be able to experience that excitement. When New Horizons flew by Pluto in 2015, holy cow, that was an exciting moment. For me, it was exciting because of kids. They were able to see exploration up hand, and with the world we live in today with communications, it was immediate. You could see this live footage of mission control and seeing them get the first images back and the excitement of sharing that discovery with the scientists and the engineers. So I'm hoping, just for our sake as a species, it's something that we can all gather around and share that excitement of space.
Yeah, I happen to agree with you. I mean, certainly we are explorers, and the great thing about exploration is you explore, and then there's more to explore. It never ends.
And the more you find, the more you realize you don't know. You're trying to solve, but it opens more questions up. With New Horizons flying by Ultima Thule January 1st, what a bizarro little body that is. And is that typical in the solar system? How is it formed? It opens up many more questions, and you want to just keep doing more.
Yeah. And also a place like Lowell Observatory. We talked about this yesterday, you and I. We talked a little bit, I remember, before you did your talk here at the Northeast Astro Forum, and we talked about, anybody can look into a telescope and explore. And that's the great thing about observatories, and Lowell is a great place, and I understand a lot's going on there.
Yeah, it's almost a spooky year in terms of anniversaries, because it's 150 years since John Wesley Powell went down the Colorado River, 125 since Lowell was founded, 100 since national park status went to Grand Canyon, and 50 since the Apollo missions, the first land on the moon. So all these great anniversaries, and they're all tied together. There's all overlap with the astronauts training at the Grand Canyon and Lowell Observatory. And so, that's something we're celebrating this year. You look back at a round anniversary, it's always a good opportunity to look back and celebrate at Lowell the discovery of Pluto and the first evidence of the expanding universe and the astronauts training. But it's also a time to look to the future. What are we going to, in 125 years from now, what are we going to look back on and say, wow, what are these discoveries? And so, that's something that we're excited about celebrating this year. And, our founder, Percival Lowell, said, what's the point of doing science unless you share it with people? And as he said, make them co-discoverers of it. And so that's something, in this 125th year, we're really celebrating and looking to the future. And so we're building a new observing facility for our guests, for instance. We have this 24-inch refracting telescope, 24 inches in diameter, 32 feet long. Anybody can come to Lowell and look through that. It's amazing. But now we're developing this new structure. It's going to be done this September. It's got the entire building rolls off on tracks. And when it rolls off these tracks, it exposes 6 different telescopes. And these telescopes, some have eyepieces, some have scientific equipment, so that our guests can really not just be wowed by looking through an eyepiece, but understand how real science is done. And so this is kind of how we're celebrating the next 125 years, is kicking off this expansion with this new facility, a brand new visitor center in the next 3 or 4 years that's going to be 3 or 4 times bigger than the current one. And so it's really an exciting time. Yeah. Celebrate the past and looking forward to the future.
Yeah. And, looking through a telescope, and some of our listeners may never have, but the excitement of feeling, and that feeling of exploration, but also the same feeling is you also feel like you discovered it yourself.
Yes.
And I think that's a great thing, and I think we have this great technology, like you say. New Horizons is going to the furthest object across in the solar system ever visited by a spacecraft, and now all of a sudden we can go all the way back to where Apollo looked through telescopes, used the airbrush to map the moon, and we can look through those same telescopes.
That's amazing, and it really connects. I like how it connects generations also. I don't know how many times at Lowell I've been in, and people come and look up and wonder what that cloudy strip is in the sky. One of those clouds, it's the Milky Way, that you can't see from most cities. And then when you see grandparents and their grandkids both looking through a telescope together for the first time, and it's something that connects the generations, and they both. It's just exciting for me. I still get a little misty-eyed when I see it after all these years, because they're discovering something for the first time. They're doing it together. Something that mom and son or grandfather and granddaughter. It's really a spectacular experience.
And I tell my listeners, and I say to them, if you haven't looked through a telescope yet, the top 10 astronomical objects I've seen are naked eye, unaided eye. Get out first and see the night sky. go to places, go out to, and go to a place like the Lowell Observatory and see some great, look through a telescope and get a close view of all those great things that to look up and wonder about.
Right, and I think that's what's great about astronomy. Anybody can go out and look at, when there's a special celestial event, meteor showers. All you have to do is go outside and lay down and look up. You don't need any special equipment. But then looking through a telescope, everybody should do it at some point. But then if you want to get into it more, you get a telescope, or you just go to star parties where people have them, and you don't have to buy a telescope, you can. But it's amazing the universe outside. We're such a small part. And to be able to explore it, naked eye or through a telescope, you can do it as much as you want. And you don't have to spend anything, or you can, this place we're at today, there are a lot of people who have spent a lot of their money to buy really nice instruments because they've just fallen in love with the sky.
Yeah. And I would recommend to anyone who hasn't had a chance to visit their local observatory to do so. It's a place that you're going to learn a lot more. Of course, we learn ourselves as we use our own telescopes, but to get to a place where you can be instructed, you have people there to help other people learn about things. It's a great thing, So I would recommend anyone to go to the local observatory.
Yes.
And is there any place that our listeners can go to that live locally here or want to visit Lowell Observatory? Where can they go on the internet or somewhere to find out a little bit more about it?
Yeah, a good way of starting is the website, which is lowell.edu. And on there you can find information about visiting, about what the research is going on there. Because it's still, Lowell is really unique, I think, because the main purpose when Percival Lowell founded it was to do research. But a close second was, like I said, let's share it with the public. And so from the beginning, the observatory opened doors so people could come up and look through the telescope. And then the third thing is we've been doing it for 125 years, so we have this history. And if you go to Europe, 125 years isn't very old. But in the American West, 125 years old, Lowell is one of the oldest scientific organizations in the West. And so we've got that modern cutting-edge research. We've got the 5th largest telescope in the continental U.S. So we've got this cutting-edge research. We've got the education and outreach. And then we've been doing it all so long. We have this great heritage. And that's just not real typical of places. They might be doing science and education, but they haven't done it very long. And so we've got all that stuff. And then our founder, who is a very curious, different person from a mainstream family, but with a lot of non-mainstream, if that's a word, I'm not sure, ideas. It's a really compelling story. So it's fascinating to look into it a little bit more.
Yeah, it is, and I think people in the Northeast, I'm not sure if they even equate the Lowell, Massachusetts with the Lowell family and how it all started. It all started here basically.
Right.
Yeah, and there's a lot of history that goes with the Lowell family from here to there. And like you said, they weren't astronomers at the time.
No, and the Lowell family, there's a lot of expectation. If you were a Lowell, you did something significant with your life. And Percival, he had a brother and 3 sisters. One of the sisters was Amy Lowell, the prize-winning poet. And one sister married a relative of Theodore Roosevelt, and his brother was president of Harvard for 24 years. And so they made significant contributions. Percival Lowell, he didn't really take on the role of older son that he was. That stayed in the community, in the Boston community. He was a wanderlust and liked to travel, so he went to the Orient and spent 10 years there writing about, and was one of the first Westerners to really immerse himself in that culture. But then founding his observatory, really building on the Lowell name. And so, you think about the Lowell family and their heritage. They're scientists with Percival, administrators, judges, just a wide variety.
Yeah, I could just imagine the cost too at the time to build something like that, without having to make any revenue from it, basically.
And that's a good point, because Percival was kind of toward the end of that generation of gentlemen scientists. They were wealthy, and they did science on their own. I mean, he went to school for mathematics, but wasn't trained for astronomy, but he had the finances, and so he began his own observatory. And you look at his legacy, you know, the biggest disappointments of his life were not finding a planet and not proving life on Mars. And so you wonder, he went to his grave probably disappointed and unfulfilled, and yet in hindsight, he started this observatory, and the search for a planet led to the discovery of Pluto, and the first evidence of the expanding universe and all these other great discoveries. And, you know, he was successful. He just didn't realize it in his lifetime.
Amazing, yeah. Thanks so much for being with us today, Kevin. I really appreciate it. And I'm sure we could talk about the history. There's a lot more history to Lowell Observatory. We'll have to talk again.
Yeah, well, that's what, you know, we've got a website. You can come and visit Lowell sometime. Or like you said, just, you know, visiting a local astronomy club and getting out and learning about the sky and, you know, some of the history of astronomy. It's a fascinating thing to look at.
Yeah, I do plan on coming this year. I hope for the very first time. I've never been to Lowell
All right.
Observatory.
Well, you'll have a behind-the-scenes tour waiting for you.
Thanks very much. Thanks for being with us today.
Thank you.
There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
As a mom.
It's great to be here. Thank you. Wow, there are a lot of you.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together, and putting your own vision on that and showing how you see the sky.
Hello there, I'm Lonnie Weegee with Celestron, and we're here live today at NEAF, and I thought I'd show you one of our new products. So what you're looking at is a brand new Roe Ackerman design. We call it ROSA. This is an 8-inch f2.0 imaging system. Now, one thing you'll notice about this, if you look at where we place the camera is designed to go on the front of the telescope. What we've done is we've taken a standard SMIT design and turned it into a ROSA design, and that means the light goes through the corrector plate, it hits a primary mirror in the back, it's reflected back up on the camera, and we get very fast wide field images. If you notice the camera we're using, it fits inside the objective so we don't block any of the light. This has been a hugely popular product for us. We're unique in this design. If you're interested in wide field imaging, if you're interested in the sky surveys, if you're just interested in a good, fast way to get started with astronomy, the Roe Ackerman is new. If you notice, we also have our new focuser on the back. This is something that's nice to have when you're doing astronomy and astro imaging. This will have steps that you'll be able to do the micro focusing needed to control a fast imaging system like this. We're very happy to have it here at NEAF. And come on by and take a look.
Hi, my name is Jeff Norwood. I'm the owner of Camera Concepts and Telescope Solutions. We're based in Long Island, New York, and we are, I'm proud to say, one of the supermarket vendors of telescopery. We sell everything and everything. From accessories to screws and bolts to things you need at star parties, all the way up to Takahashi's and you name it, all the rest of that. So at our booth here, we've been coming here to NEAF for over 20 years. We basically bring the entire store with us. So we've got lots of goodies, and of course, everything's on sale, great deals. Our website is www.cameraconcepts.com. Please visit us. We support what we sell. We've got experts in the field on staff to help you with astrophotography or all your visual aids that you might need. So thanks a lot, and bye.
Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us. Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together, and putting your own vision on that and showing how you see the sky.
And now, ladies and gentlemen, the hardest working MC in the cosmos, Vincent Coulihan.
Hey, thank you very much, folks. Thank you for being here today. It's truly a pleasure as we wrap up NEAF 2019. I do want to take this time to acknowledge and thank first Rockland Community College for us to use this facility, number one. Thank you very much. Number two, the members of the Rockland Astronomy Club, how this has been put together for you, and we certainly hope you've enjoyed the program. And a big shout out to Ed Siemens, who's really been the spearhead and the leader behind this operation. So thank you very much. Give him a big thank you. As we come to the end of this forum, we are absolutely fortunate to have our next keynote speaker. And I'm going to take it from reverse. He is a venture capitalist, an entrepreneur, a physicist, a fighter pilot, retired colonel from the United States Marine Corps, an astronaut who followed up and was the first crew following the Apollo 1 in October 1968 for Apollo 7. Please extend a warm welcome to NEAF, Walt Cunningham. Welcome. Right over here, my friend.
Thank you again. I tell you, I never know what to do with this kind of a reception. It's so warm and feely. So thank you for being here. And I noticed that the name of the talk I was going to give here, The Golden Age of Spaceflight, that's slightly different than was in your program. But I've enjoyed it here for the last 2 days. It's one of the most impressive kind of get-togethers I've ever seen. How many of you here have personal memories from the time of Apollo? That's not bad. Wish I could remember that well. Well, when Apollo was mentioned today, it's a little bit different. The public recalls that, well, they recall Apollo 11, of course, Neil Armstrong, first man on the moon. And they might remember Apollo 8. That's when we escaped the Earth's gravitational field. They went out to the moon. Sometimes they'll remember Apollo 13. Remember, they had a movie about that, so that brings it there. But the public at large, they rarely recall Apollo 7 or Apollo 9, because those were test missions, the command module and the lunar module, and those were tested right here in Earth orbit. So the Apollo program were the only ones that didn't escape the Earth's gravitational field. But both of those test missions, both of them played a critical role in the most historic achievement in our nation's history, landing a man on the moon. Well, for space enthusiasts, the good old days, it was the time of Apollo. And that's why we refer to that as the golden age of spaceflight. The Apollo program was more than just missions. And today I'm going to speak both on the missions and on factors that I think help make Apollo great. Motivation, attitude, inspirational factors. And I have to tell you, some of those things only became apparent to me when I got older and a little wiser. And I would encourage you, when I get through, to ask me any questions on any aspect about it. I'll try to answer things. And we've had a number of impressive space programs after Apollo, but it's in a different kind of nature. So now let's see if I can make this thing work. Do I point it at something? Ah, okay. Well, we'll see how it goes. The International Space Station actually is one thing, but the space shuttle, in my opinion, was the greatest flying machine in history, ever. And the International Space Station, that's the most impressive manned satellite ever. And with more space science today, even the groups of people that are familiar with it are looking into it on their own drive. But this more space science today than ever before. Then why is space not a bigger factor in today's society? Don't know. What has changed in our society? Well, I think it's because basically our society is changing. Apollo was a story of exploration and adventure. My generation, we had the opportunity and the courage to look around the moon and reach for the stars. We didn't shy away from the unknown, and we were willing to take a risk. We were exploring the world's next frontier. And today, the entire world takes pride in what was man's greatest adventure from those days. And you might ask, what is an adventure? Well, in 1994, a Frenchman by the name of Delage, well, he held a press conference to announce that he was going to swim the Atlantic. When he was asked why, he said, because it is an adventure. And then he explained, to be an adventure, oh, they're working, okay. To be an adventure, you must satisfy 3 conditions. You must advance human knowledge, must have a real risk of dying, and it must have an uncertain outcome. Well, that was the Apollo program, to land a man on the moon. Incidentally, Monsieur Delage, he did not make it. But in 1998, another Frenchman by the name of Lecomte, he actually swam the Atlantic. 500 years ago, the next frontier was the New World. None of you are old enough to remember, but back in the 15th and 16th centuries, England, Spain, and Portugal, they were crossing the seas trying to expand their country's greatness. And when we got to Ferdinand Magellan, back in 1519, you may remember, if you've ever read about this, that he set sail on one of the most famous voyages in the history of exploration, and he had this to say. He said, "It is with an iron will that we embark on the most daring of all endeavors, to meet the shadowy future without fear, and to conquer the unknown." Well, Magellan's voyage, that was to be the first voyage around the world, around this planet Earth. As the exploration of the New World was inevitable 500 years ago, well, so too is our exploration of space. Is that me? This new ocean, it's more pristine than was the New World before the voyages of Columbus and Magellan. Back in the 1960s, we reached for the heavens. That was to open up the next frontier. And it's one of those whose farthest shores we can never reach. And while the voyages of Columbus and Magellan, they took years, astronauts make that same trip in minutes, 90 minutes around the world. It wasn't always that way. Too many, well, I'd have to say in 1960, many predicted a catastrophe for man in space. Some doctors thought that man's kidneys or his liver might fail, or that our eyes would change shape. In spite of that, in 1961, a group of Americans decided and announced to the world that America was going to the moon. And within 10 years. The President Kennedy at the time, then President Kennedy, he had this to say, and I quote him. He says, "We will land a man on the moon and return him safely to Earth in this decade. We choose to do this not because it is easy, but because it is hard. Now, that statement at that time must have seemed incredulous to the world. You see, we were throwing down a gauntlet before the Soviet Union, challenging them to a technological fight to the finish. And at that time, not a single American had yet been in orbit. And I think that was the real secret behind what went on during Apollo. But President Kennedy, he was willing to take a risk. And it wasn't just a technical risk and a human risk. No, it was also an economic risk and a political risk. That took initiative. It took leadership. And today, that goal is history. 50 years ago, it became another milestone in the history of America. Only 193 years after establishing an American flag on this planet, we planted it on a foreign body in the universe. That took a team willing to stick their necks out. And while our engineers, managers, and astronauts were willing to risk failing, we never thought about failing, believe me. We were racing our competition to land a man on the moon, and we refused to lose to anyone or anything. We shared a common dream to test the limits of man's imagination and his daring. That attitude, that enabled us to overcome every obstacle in one of the most challenging and risky endeavors in history. And that wasn't just for the Americans. The entire world takes pride in man's greatest adventure. Any project as complex as Apollo requires three things: the resources, the technology, and the will to do it. And driven by the Cold War, all three of those came together in the 1960s, and we went to the moon. Excuse me. It was only 3 generations between man's first flight off the Earth and man's first orbit around the Earth. 3 generations. Today, we've raised 2 generations for whom man's first flight into space is only something that they've read about in the history books. Some of you might ask, why was the job of riding a flaming rocket into orbit exclusively for fighter pilots and test pilots in their 30s? Well, at the time, it was considered too tough for anyone much older. It was thought that only an experienced and a youthful fighter pilot could endure the wear and tear. It was a young man's game, or so we thought. That when Wally Schirra, commander on our mission, when Wally Schirra left NASA, he was the oldest active astronaut at the age of 43. Today, I think that the average age in the astronaut office, which is much, much bigger, more people, I think the average age is over 45 years. So times they are changing. Back in those good old days, we were hired based on our experience and our qualifications. We were all highly motivated, competitive self-starters. As fighter pilots, we had survived pre-screening and filtering in military careers of 12 years or more. And that's where we spent our lives, facing risk. Surviving in a challenging and dangerous profession makes you well aware of where you're going and how you will get there. And I can tell you, we could depend on each other for our lives. So how did I become one of the first 30 astronauts? Well, I guess some of you may prefer to ask why. I decided to do that. Well, back in 1961, I was a Marine Corps fighter pilot. Had about 2,000 hours in jet fighters. I was working on a doctorate in physics at UCLA, and I was a part-time employee at the RAND Corporation in Santa Monica. I'd read about the Mercury astronauts, and I had envied them somewhat. Well, I can tell you this. On 5 May 1961, I was driving to work at the RAND Corporation from where I was living in San Fernando Valley. It was a little before 7 a.m., and I'm listening in my car. That was the morning of Alan Shepard's flight. When it got down to about 5 minutes left, just a little before 7 a.m., I had to pull over and stop. I couldn't keep driving anymore. And that was a little before 10 a.m. down at Cape Canaveral. So I was sitting in the car. I was listening to the countdown, Alan Shepard's countdown. And here I am parked at the side of the road. 3, 2, 1, liftoff. And I heard this voice screaming out around me, "You lucky son of a bitch." Well, that was me doing the screaming. And I'll tell you this, 2.5 years later, I was sharing an office with that same Alan Shepard. In 1963, I was one of 770 qualified applicants for the third group of astronauts. Let's see, I think we have Alan's. Oh, well, I got that out of place. Okay. I was one of 770 that was qualified applicants for the third group of astronauts, and I ended up being one of 14 that were selected. There's a group of 14 astronauts that were selected. We were the third group of astronauts. My observations on it, I can tell you this. They were all bright, healthy, in good physical condition, motivated, competitive, self-starters, with a strong feeling of self-identity and self-confidence. We were aware of where we were going and how we would get there. I guess some of you might say that was ego, and it may have been. Some of us may have thought that fame and fortune lay ahead. Actually, the reality was, 3 years later, 4 of our 14 were dead. For details, I'll refer you to my book, The All-American Boys. And why did we become astronauts? It wasn't for the money. I can tell you, I started college when I was about 25. And I had transferred to a reserve squadron so I could go to college. That left me then, when NASA selected me, as a civilian because I was a reservist and not on active duty at the time. My starting salary as an astronaut was $13,050 a year. Now, let me surprise you a little bit. Actually, by the time I left NASA about 8 years later, I was all the way up to $25,000 a year. But, you know, God, I went back and calculated one time that during the 11 days of Apollo 7, the 11 days of that mission, I had earned a little less than $660. Hell, at 50 cents a mile, I would have made $2.25 million. And I have to tell you this, too. I had no NASA life insurance. At the time, there was 4 of us that were considered civilians, and therefore we were part of the civil service stuff. And they were just renewing their life insurance for NASA, and if they had included us, the 4 of us in there, then overall it would have been too expensive for all the other civilian people working for NASA. So we didn't have any life insurance with NASA. I can tell you this, though. Overall, that was one of the world's great jobs. The 1960s and the 1970s, those were the golden years and the golden age of manned spaceflight, much like the 1920s were in aviation. We had no biplanes, and we didn't have silk scarves blowing out of the cockpit of those airplanes. But we felt like it. It's the way it was. It's the T-38s that all of us loved flying. I got a lot of time in that. We had 30 astronauts and 30 T-38s. So we thought about it as the last great flying club. Anyway, we had another half a dozen other kinds of airplanes around there also on it. We loved flying airplanes and we loved riding rockets. Not the least of our motivations back then, really, were doing something for our country. And that's like the feelings of my boyhood hero, Charles Lindbergh. You may remember the first man to fly the Atlantic solo back in 1927. I met Charles Lindbergh in 1967, I think it was. Anyway, at that time, here's what he had to say, actually, in 1969. I think it was in his book. He said, as a student pilot at the age of 20, when aviation was much more dangerous than it is today, I concluded that if I could fly for 10 years before being killed in a crash, I would be willing to trade an ordinary lifetime for that experience. Well, I can tell you, that's how we felt about riding a rocket into space. And it's a good thing we did. In 5 years, we had lost 7 of our 30 people in aircraft and spacecraft accidents. In the 50 years since that time, we've only lost 13 more of our 30 that are gone. In 5 years, we lost 7 of our 30 in those accidents. The most noteworthy loss, of course, for any of you out there in the audience this afternoon, most noteworthy loss was the Apollo 1 fire on the pad. 3 good men paid the price of progress, and I lost 3 good friends, Gus Grissom, Ed White, and Roger Chaffee. Actually, we were the backup crew on that. Excuse me. Here's the, okay. There's the prime crew and the backup crew. The cause, regardless of what you hear a little bit about today, but the cause is a bit unknown still. But I think that our overconfidence at the time was one of the factors. Wally Schirra, Don Isley, and I, we had spent 8 months as a prime crew of what would have been Apollo 2. Working at the North American plant out on the West Coast, working on the design, manufacturing, and testing. And as that schedule kept slipping, we had more and more problems back and forth with the contractor. And Apollo 2 was canceled. That was after 7 or 8 months. Then we became the backup crew on the first Apollo mission, on Apollo 1. 3 months later, as you were aware of, the Apollo 1 crew died in a fire on the pad. 3 weeks later, after that, we became the prime crew on the first Apollo mission, which ended up being renamed Apollo 7. Excuse me, 21 months later, 21 months after that, we became that crew, and after 1,040 changes in the spacecraft, Apollo 7 was like, it was like the mythical phoenix rising from the ashes of the Apollo 1 fire. I tried to work that out into the patch one time, and they refused to use it, so we didn't get to show it rising from the fire. Apollo 7, that was the most ambitious effort to make up for lost time. It was a planned 11 days to test all of the propulsion systems, all the spacecraft systems, docking, rendezvous maneuvers, ground systems, and anything else that was in that spacecraft. Actually, the S-4B, you're looking at a picture here of the S-4B over the Kennedy Space Center. And to our surprise, actually, Apollo 7 survived the full 11 days. I was sitting in the right seat. I ended up taking this picture. But we were taking pictures of the S-4B because we were trying to, working on the simulation between docking with that to get out to the moon. And it was film in those days. We didn't know what was in the background, actually, until we got back and they got the pictures developed, and we got to see those. I love that picture because that's where we lifted off from. Right down there, you see what looks like an island. This is the second time around. 3 years before, that's where we lifted off on that. So to this day, that mission was running so well that we added 4 more mission objectives while we were in orbit. And today it's still the longest, the most ambitious, the most successful first test flight of any new flying machine ever. Actually, I think it was an amazingly good spacecraft. And, oh yes, I forgot to mention, surprise, we also got an Emmy for the first live television from space. It was kind of interesting because we were taking some pictures, and that's about the best you can. That's an improved version of those pictures since we got back, but those were live pictures. And I never forget, Wally and I talked about, well, if we fly out to Hollywood, we'll have a good weekend out there, and we'll get that Emmy that they said they awarded us. NASA says, you're not going. A couple weeks later, I get a box that comes into home, and in that box was an Emmy that's now there. I'm frequently asked, were you afraid? Well, I can tell you this, afraid of the mission? No. The only fear that I can recall at the time was the fear of failure. Each member of our team had the same thought. If this mission fails, it won't fail because of me. Now, we weren't afraid of accepting the challenge, but having accepted that challenge, we were afraid of being found lacking by our peers. Actually, Apollo 7 was the first step of an orderly plan to land a man on the moon. And here are the 5 steps to the moon. And this plan had, as I said, 5 giant steps. Everyone on our team, not just our crew, understood that plan. Apollo 7, develop and test the command module systems and operations. Apollo 8, that was to overcome the psychological barrier and escape the Earth's gravitational field to go out around the moon. Apollo 9, that was to test the lunar module in Earth orbit. And that lunar module had no heat shield, so it was very important that they managed to dock again with the command module. No heat shield, no reentry capability. Apollo 9, that was to test the lunar module. Excuse me, that was Apollo 9. Apollo 10 was the dress rehearsal of the first lunar landing. And they went down to 50,000 feet above the moon's surface. And even though some of the stories they like to talk about today that it might have gone ahead and landed, believe me, it could not land. It was too heavy to do a land and recovery on that. And then Apollo 11, we all know. All of you know. Apollo 11, that was the last 50,000 feet for the first lunar landing. And when Apollo 11 touched down, with 17 seconds of fuel remaining, boy, we all started breathing again. And Neil Armstrong, he stepped off into history. When the Apollo program is mentioned, you probably immediately think of Neil's words, you know, a small step for man, a giant leap for mankind. That's certainly one for the history books, believe me. But there were a couple of other statements that still stick with me today. How about Jack Schmitt? He was on Apollo 17 and the only geologist that we were able to send to the moon. That's Jack down there next to that rock. But he was the only geologist to go to the moon, and eventually he became a U.S. Senator. But after the mission, about 3 weeks after the return, that crew was addressing a joint session of Congress. And when Jack addressed the Congress, he had this to say, and it stuck with me since. It's an accurate observation. It says, "I would like first to tell you about a place I have seen in the solar system, the Valley of Taurus Littrow." And then he went on to say, "This valley has been less changed by our being there than we have been changed for having made the journey." Certainly true today. Or, you may not be aware of the fact that on Apollo 11 they carried microfilmed messages from the leaders of all the free nations of the world at the time, and they were left on the moon by Apollo 11. Microfilm messages. Those were critical and very impressive in those days. It's different. And I carried one of those messages with me for several years before I finally gave up on it, and that was the one by Australian Prime Minister Jack Gorton. He had this to say, about 2 sentences of praise. Then he went on to say, "May the high courage and technical genius which made this achievement possible be so used in the future that mankind will live in a world in which peace, self-expression, and the chance of dangerous adventure are available to all." What a wonderful wish. You see, that chance of dangerous adventure means accepting the risk of failure. And if you're not willing to risk failure, in my opinion, you don't deserve to win. But when you do win, you win big. And that's true in all fields of human endeavor. Looking back, the Apollo program had it all. It had challenge, competition, imagination, leadership, teamwork, technological breakthroughs. It also had its risk and its uncertainty. It had its chance of dangerous adventure. And it wasn't just the risk of dying. Men did die. Others were survived and saved only through heroic efforts. There's the Apollo 13 explosion. I'm sure some of you remember that personally on that. All of the Apollo missions returned to Earth. We had 6 landings. 12 men walked on the moon. We advanced man's knowledge in dozens of fields of endeavor. And each mission was uncertain until splashdown. That certainly met Monsieur Delage's definition of adventure, if you remember, on that. And the world saw, whoops, it didn't go. There's a reminder of Monsieur Delage's criteria there. The world, at the time, the world saw Apollo as a technical achievement by men who worked and think like machines. But we weren't computers or robots. We were warm, feeling, emotional, committed individuals. And 500 years from now, I have to tell you, only one event of the 20th century will stand the test of time. And that's man on the moon. That was the most spiritually uplifting event in our lifetime. You see, for a brief period during the time of, of Apollo, our society, it felt good about itself again. We felt together. We felt supreme in our ability to accomplish anything that we set our minds to. It was an adventure that expanded the envelope of human experience and proudly proclaimed to the world that we accepted no limits on what we could accomplish. As astronauts, we were at the tip of that spear, and we got the glory. But the success of the Apollo program was due to the collective effort of about 400,000 members of a team in government and private industry at that time. Against enormous odds with the whole world watching, a group of engineers, scientists, and managers accepted the challenge and took the risks. And I have to tell you, that team changed the way that we all perceived our world. Commercial spin-offs from the technologies that were developed to make it possible, they're providing a financial return. Even today, they are providing a return. Today, our society seems intent on eliminating risk and looking for absolute assurance that something can be done before we commit to do it. And we're overwhelmed with politically correct decision-making going on in our culture and society. Even our space program is beginning to reflect today's risk-averse society. NASA seems to be evolving into a more bureaucratic and less efficient agency. That once rambunctious American spirit of innovation and adventure is being paralyzed by the desire for a risk-free society. Well, I can tell you this, exploration is not about eliminating risks. It's about managing risk. Today we hear incessant talk of limits, usually expressed as a shortage of funds, when our only real limits are those that we place on ourselves. Today, though grand aspirations are usually at the mercy of politicians, they are possibly the most risk-averse segment of our society. And they focus almost exclusively on their own survival, not on having the right stuff. Well, I don't think that we can just be politically correct. We have to be willing to do what is right, even if it's unpopular. I hate to say it, but NASA has been sliding down this hill for some time. And safety can never be guaranteed when you're exploring the unknown. To venture out into unexplored frontiers, it has always been necessary that the explorers be willing to die for their efforts. Otherwise, it simply cannot happen. Remember Magellan? When he set out from Spain 500 years ago, he set out to explore the globe, and he left with 5 ships and 270 sailors. When they returned 3 years later, only one of those original ships was still there. There was no Magellan. He was gone. And only 18 of those original sailors were still alive. Well, you could say that my generation met one of its obligations. The Apollo program, I think the Apollo program brought together thousands with a shared dream and supreme confidence. They were dedicated, motivated, and committed individuals. They were willing to accept whatever risk was involved and to get the job done. Initially, the Apollo program was all in our minds. And what was accomplished? We staggered other men's minds and expanded our universe. We showed that if you're willing to dare greatly and to risk failure, you can change man's view of his future forever. Personally, I feel fortunate to have lived when I did. And I am proud to have played a small role in a historic accomplishment. Thank you very much. Thank you. Thank you very much. Thank you. Thank you. I'm prepared to, well, I was going to say to answer any questions you might ask, but I think it'd be more honest, I'll say I'm prepared to try to answer any questions that you might ask. And as long as we do. Yes, sir, right here.
How involved was your crew in the redesigns and changes made to the command module after the Apollo 1 fired?
I guess thorough, how much was our crew involved in the redesign going on after the Apollo 1 fire? We lived with those vehicles back in those days. And of course, a lot of that work was going on at North American out in California. But we were involved in virtually every step. We did not have the total control because in those days, astronauts had a lot more influence than they do today. And that's because the organization and management aspects have evolved. I feel kind of sorry for them today because there's some place down here in the list and they're told what's going on, and it's tough to fight it, I'm sure. But they also have a different kind of attitude. Back in our day, we had people from our office that were involved right up to the top. Some of them even went to the president to try to get something done. So we had a lot of, I won't say so much a lot of influence, so much as we had a lot of efforts to do that at the time. Yeah. Yes, little one right there. How did it feel when I was on Apollo 7? Well, it felt really great after we got into orbit. But people will have a hard time understanding this part about it. When we had worked so desperately, sometimes 24 hours a day we were working to get this spacecraft ready. And we got down to the scheduled launch and liftoff, 11 o'clock in the morning, I think was what the time was. And we wanted to do it perfect. Maybe you can call that a mental problem, but that's what we had. Maybe it's a psychological problem, but that's what we wanted to do. And they got down inside the last hour on the countdown, and they wanted us to stop the clock so that we could change the pressure. I think we had to get it up 2 more pounds in one of our tanks. And I'll never forget that we got irritated at that, and we ended up, to do that, we ended up being 2.5 minutes late at liftoff. And I can remember we were pretty well ticked off at that. And I think Wally said something about that too when he was talking to it. But I think that was reflective of an attitude that we used to have in our culture and our society. Today, there's people, I'm sure, that feel that way too. But we're not prepared to accept some of the attitudes that we used to do 40, 50 years ago on it. But that's what we want. We were a little ticked off because we were 2.5 minutes late at liftoff. Yes, sir? Was it a pain being on? Well, I'm sure most of the guys, regardless of who they were flying with, at some time or another during that mission, they had a pain. You can't really say, but I tell you, the Alan Shepard flight had nothing to do with it. I used to race cars with Alan Shepard, but when he was flying, that was it. I had nothing to do with it. I was working on the Skylab branch, the astronaut office at the time. But I think that a number of things kind of got complained about. Today they would in it. I can't support everything that was done in favor of the crew in those times, but almost all of it I would, because we had a different attitude. Management had a different attitude. The money they spent on it, the entire Apollo program, total, it was budgeted for $20 billion, ended up costing $25 billion, so it was 25% over budget. But look at what they did. Amazing things that they did with it because of how we were committed and what the prices were then. Now it's hard to figure out what to expect because they talk about, like right now, they start up, they want to talk about going and landing on the moon again in 5 years. I don't know if we're going to do that or not. Might be a decent objective if you have the goals. It depends on what goals you have to do or what you want to try to do about it. We've landed on the moon on Apollo 11 through Apollo 17, and there's been a lot of unmanned stuff on that too. So you've got to have the right kind of focus that tells you what you are really out to accomplish. To just do these things for public relations, in my opinion, is not the right direction to be going. You need to be doing it to fill the needs of our society, our culture, and to make sure that the world at large sees us as the #1 technology nation. Yes. What?
As an individual, what's your favorite memory and the most important thing you learned during your time as an astronaut?
Oh, boy, that's what's my favorite thing learned as an astronaut? What was my favorite thing? My favorite memory. Well, I'll tell you, I think my favorite memory was when we launched and started up the spacecraft and started climbing, and I knew that we were going to go into orbit. That was probably my favorite memory on that. What was the second part? What's the most important thing you learned as a Most important thing I've learned. In retrospect, one of the most important things, I couldn't tell you exactly what, but one of the most important things I can tell you is what I've been talking about here. And that's your attitude about, you got to be willing to stick your neck out to get someplace. Today's society, today's culture, most of the people probably see that as an improvement. Personally, I don't. I think that what you need to do is you not control everything that everybody does. You've got to be willing to accept people willing to stick their necks out and to try to accomplish things. I also don't believe in having a government that ends up supporting all kinds of things of one group or another. on it instead of narrowing all that stuff down and being very careful in what the government supports. I'm definitely not a supporter of how our society has been evolving for the last 20, 30 years. I apologize for some of you people for that, but that's the way I am. I don't have to worry about it. I'll be gone for long. Yes, ma'am. To have what? Do I think that it's a good thing to have a base on the moon and talk about in preparation for the Mars expedition? I do have opinions on that. There are things that we can do to our benefit that help society in going back to the moon. I look at now at what we've done on exploration of Mars, unmanned exploration of Mars, and I can tell you this, we know 1,000 times as much stuff about Mars today as we ever knew about the moon before we went to the moon. Will we eventually go to Mars? Possible. I don't see it as a completely analogous to going to the moon. And as a matter of fact, I see exploiting the moon on whatever you can do there and trying to take advantage of it and to develop capabilities for other planets, I see that all more important to Mars. The unmanned exploration of Mars has been amazing, in my opinion. And now they're talking about going to Mars 5 years, 10 years. One, with human beings, it's impossible. The question is, should we do it? You look at the costs, you go back today and look at the costs, unbelievable difference in the costs. The Apollo program, that was planned to be a $20 billion program. Turned out it was all of $25 billion. If you adjusted that to today's dollars, that's like 140 or 150 billion dollars. And you have NASA now, whose budget is like, let's say, down around $20 billion. And they talk about, going to Mars or back to the moon and things like that. Believe me, the numbers don't add up correctly for me. I could be wrong, but that's my look at it. Okay, I got more questions. Okay. Some of you pointing at, oh, okay, there in the middle. Thank you. What was my favorite what? Favorite site? Well, I'll tell you, when we finally got around to being able to look, boy, I tell you, anything you could look and see was your favorite site. It was unbelievable. The public today has a kind of a hard time understanding that those were old-fashioned days. Now you hear some little complaints once in a while if they don't have 100% communications, for example. Well, on Apollo 7, Earth orbit, we had about 4.5% of our time. It was Earth-to-ground communications, which we thought was good, except the times when we had communications. We had so much work to do, so much development, so much tests that we already had done in there that we might be involved in some part of it, and then one of the guys, Wally Schirra, he might say, God, you got to hurry up down there. We got communications coming up in 4 minutes. Okay, people today have a hard time because they're 100% communications. We liked to have the opportunity to accomplish everything we knew that we had to do to develop and improve that spacecraft. So that was one of the differences that was there. Also, what people today have a hard time understanding. I told you, about 5% of air-to-ground communications. When we were in orbit, we didn't have an attitude that you held like you're seeing now on the space station. We were drifting because we didn't have enough fuel to hold that. And when you stop and think about it, here we had 5 windows when we started. A couple of them deteriorated. But the 5 windows, about 150 degrees. And you're in a spacecraft that's drifting. Now the percentage of the universe that you're looking over, the percentage of that you can see the Earth is very small. If that window happens to be pointing down, and if it's not blocked up yet, which they got. But when that happened, even if you're pointing down, you're looking at the Earth, 55% of the Earth's surface was covered with clouds. It was hard to get pictures. When you have to be looking down, it was covered with clouds. Every 45 minutes, you went from daylight to night, or night to daylight. And so you had to have a couple minutes in there to allow you to get the lighting good enough to get pictures. Talking about getting pictures, you may not know, what we had was a Hasselblad camera. Now, I've had a lot of people take my picture around here in the last day or two, and they might go 6, 7, or 8, just click, click, click. We had a Hasselblad with our film, and the total number of shots for the entire 11-day mission, 540. And so we paid a little bit of attention to that, but that seemed kind of adequate too. But our whole universe and our attitude is changing. And I may not catch up with it, and that might be part of the reason why I'm not terribly satisfied with some of the changes that's going on today. But it was a different kind of world, and I am so glad I was part of what was exploring it. Okay? Way up there. Okay, the question was what I learned in training, did it prepare me for the Apollo mission? I'd have to say yes. We all were used to that. We were all fighter pilots in those days. We all knew that you have a certain amount of risk involved with what you did. And I think we had maybe a better attitude about what it took to survive in the new atmosphere of leaving the atmosphere and going in space than they do today. In fact, some of us, I'm sure today, of the 30 people we had, it was mostly got us all the way through the Apollo program. I think that a lot of those 30, we might not even get approved today because mostly they're long for the ride, really. There's some operations that's cranked in there, but it's not the same thing as you had when every aspect of it is dependent on the way the crew can handle the malfunctions when they happen. Today, it's oriented differently. It's something that we have done. We have evolved our society, and they have a different kind of attitude than we had back then. How about one last question? Where? I can't see. Okay, all the way up. Okay. Okay. Okay, I'll make that the last question. And I don't think I heard exactly what you were asking, but I have done a lot of thinking about Elon Musk and what they're doing there. And up until the time, I was very pessimistic until he started recovering boosters on those things. I was terribly impressed with that. But he's also the guy that's stupid enough to talk about us going to Mars in another 5 years. Believe me, do not have the ability to survive for long enough on Mars until you can get another launch time in order to get back. We'll eventually develop some of those things, but the question is, do we need or have to? Now, they like to talk today of saying, well, the Earth is going to blow up out here sometime, and we need to be able to send people there to survive. Well, I happen to be pessimistic about that, but you're entitled to have some other thought. But do I like? I like the way that civilians are doing some work now, because as agencies grow and age, they change, they evolve, they add levels of management on it. It becomes less efficient than it was back, in this case, NASA in the 1960s. That's just the way it does today. So we need to depend on the civilian agencies because they're still trying to make a profit. They're still trying to hold the costs down. And I find them very essential to future exploration. But I don't know, everybody may not agree with me, so I'll just tell you. So I want to thank you for the questions and having the opportunity to talk about some things that I've done a lot of thinking about over the years, but rarely do I get a chance to tell everybody what I think. Thank you.
Thank you very much, Walt.
Huh?
Great job. Thank you. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you,
very much.
everybody. Okay. Thanks.
Ah. There is not another field of human contemplation so wonderfully rich as astronomy. It is so easy to reach, so responsive to every mood, so stimulating, uplifting, abstracting, and infinitely consoling. Everybody may not be a chemist. Everybody may not be a geologist or a mathematician, but everybody may be and ought to be, in a modest personal way, an astronomer. For stargazing is a great medicine for the soul.
Take you on a journey to the outer reaches of the solar system.
As a mom.
It's great to be here. Thank you. Wow, there are a lot of you.
My name is Grant Regan, and I live in Los Angeles. I first got into astronomy. Just as a kid, I was always interested in the sky. I'm situated on the west side of LA, and the light pollution is pretty bad anywhere in LA. And even if you drive an hour and a half out, you'll still see the light dome of LA in the south or in the north, depending on where you go. The ROSA 8 has a very fast system, and because of that, you can take images that would on other scopes take up to like 30 minutes. You can take on the ROSA in a minute or less. And that difference is huge, because what matters is that you can take short exposures but get that detail and not have star trailing or anything like that.
And basically I'm taking this from a heated car when it's almost freezing outside. There's a telescope right there, so I'm just remote control using it. This is just a lone exposure. It isn't even a raw image. It's not processed at all, so once we process these, they're gonna look amazing.
With astrophotography, it's not just taking a shot and saying like, this is what's on the sky. It's really taking multiple shots, stacking them together, and putting your own vision on that and showing how you see the sky.
Hello there, I'm Lonnie Ouija with Celestron, and we're here live today at NEAF, and I thought I'd show you one of our new products. So what you're looking at is a brand new Roe Ackerman design. We call it ROSA. This is an 8-inch f2.0 imaging system. Now, one thing you'll notice about this, if you look at where we place the camera is designed to go on the front of the telescope. What we've done is we've taken a standard SMIT design and turned it into a ROSA design, and that means the light goes through the corrector plate, it hits a primary mirror in the back, it's reflected back up on the camera, and we get very fast wide field images. If you notice the camera we're using, it fits inside the objective so we don't block any of the light. This has been a hugely popular product for us. We're unique in this design. If you're interested in wide field imaging, if you're interested in the sky surveys, if you're just interested in a good, fast way to get started with astronomy, the Roe Ackerman is new. If you notice, we also have our new focuser on the back. This is something that's nice to have when you're doing astronomy and astro imaging. This will have steps that you'll be able to do the micro focusing needed to control a fast imaging system like this. We're very happy to have it here at NEAF. And come on by and take a look.
Hi, my name is Jeff Norwood. I'm the owner of Camera Concepts and Telescope Solutions. We're based in Long Island, New York, and we are, I'm proud to say, one of the supermarket vendors of telescopery. We sell everything and everything. From accessories to screws and bolts to things you need at star parties, all the way up to Takahashi's and you name it, all the rest of that. So at our booth here, we've been coming here to NEAF for over 20 years. We basically bring the entire store with us. So we've got lots of goodies, and of course, everything's on sale, great deals. Our website is www.cameraconcepts.com. Please visit us. We support what we sell. We've got experts in the field on staff to help you with astrophotography or all your visual aids that you might need. So thanks a lot.
Hi, I'm Kelly Beatty from Sky and Telescope. I'm a senior editor on the staff. I've been on the staff of Sky and Telescope since 1974, hard to believe. But I'm still having fun, and why wouldn't I? We're a very important part of the amateur astronomy community, just as NEAF has become a kind of essential go-to place each year for many thousands of people in the amateur community. We're here, we're one of the co-sponsors of NEAF, and we are dedicated to being a major part of that. You know, people think of us as just Sky and Telescope magazine. We're actually much broader than that in a couple of respects. One thing is we do a lot of outreach. We provide a lot of materials for amateur clubs across the country when they need materials to distribute at their star parties and such. And we also do some products that are maybe not what you'd expect from a magazine. I've got a couple here. We have a whole line of globes that we sell. They're really great. This one, for example, this black beauty is our celestial globe, which shows all the stars in the sky down to 5th magnitude. And then this is our new one, just about to be produced. It's a globe of the Earth, obviously, but it shows all total solar eclipse paths until the year 2100. So if you're the kind of person who likes to plan ahead, this is just the globe for you. You'll know where to be in 2024 and beyond. The other thing we do a lot of is tours. Speaking of those eclipses, we've actually got a whole bunch of tours that we do all over the world. We just had a tour finish in Finland to go see the auroras. It was very successful. This summer we have a tour of Chile coming up for a total solar eclipse. We've got an observing tour planned for Australia that is just going to be killer. So for all these reasons, Sky and Telescope sort of considers itself the essential guide to astronomy. And again, we've been at this for 75 years, so we really have a good handle on the amateur community. We're from the amateur community. We'll always be a part of it. And we are so grateful to the organizers of NEAF, Ed Seaman and the rest of the crew here for welcoming us every year and being such gracious hosts in this amazing setting where the sky is really the limit. So thanks very much for the opportunity to chat, and we'll see you here next.
Hey everybody, Scott Roberts here from Explore Scientific, and we're here in Suffern, New York at the epicenter of the universe, the Northeast Astronomy Forum. This is a great event that happens every year, and it is in fact the world's largest astronomy trade show. Every manufacturer is here. You've got telescopes, you've got eyepieces, cameras, observatory domes, and tons of software. Some of the greatest retailers are here as well. You've got, Woodland Hills and High Point, Camera Corner, many others. And so it's just a really fantastic place to be if you're into astronomy. Here at Explore Scientific, we got behind me is the Explore First Light series. These telescopes are intended to get you started in astronomy, whether you're interested in deep sky or planetary. We've got it all. And so we're really happy to be here with you, and please come and visit us.
We're live here at the NEAF conference in Suffern, New York, and we're from Lowell Observatory. And Lowell Observatory this year is a great year because we're celebrating our 125th anniversary. So 125 years of great discoveries, and that's really the legacy of Lowell. We've been doing important research from the discovery of Pluto to VM Slipher's recessional velocity work to current research using our Discovery Channel telescope to discover planets around other stars and a lot of other great work. So we're doing a lot of great things, and it's also a great place to visit.
And we're doing all kinds of neat things this summer to commemorate our 125th anniversary. So we have coming soon the opening of our Giovanni Open Deck Observatory, which is going to feature 6 modern telescopes fully dedicated to public observing. A great suite of instruments there and some nice interpretive locations to look at and learn more about the telescopes and astronomy. And then of course this summer we're also celebrating the lunar legacy for Flagstaff as we approach the 50th anniversary of the lunar landing.
And it really is a great time to celebrate the 125th of Lowell and the 50th of the first moon landing. And all the astronauts who walked on the moon trained in northern Arizona. And so we have a community-wide celebration at Lowell Observatory and other science centers. Even our businesses are getting into it, creating specialty drinks like the Earthrise cocktail and a special moon pie and all sorts of other great desserts. So it's a really great time from now through the end of 2019. We're doing this Lunar Legacy celebration, plus all the stuff we normally do at Lowell. And we're also opening this new open deck observatory that Danielle mentioned that's going to change how we do astronomy outreach, because we have big 32-foot-long telescope to look through, plus this suite of state-of-the-art telescopes that our visitors can really see what it's like that real scientists do, and also just the wonder of looking through an eyepiece and gazing in awe at the universe. It's just something that we as humans, it really captures our spirit. So there's a lot of great stuff like that to do at Lowell.
And speaking about looking through the eyepiece, there's nothing like looking through the 24-inch Alvin Clark telescope, refractor built in 1896. So it's 123 years old this year, and we just restored it a few years ago. It's gorgeous looking through, and you can do that on Mars Hill in Flagstaff. So lots going on this year.
Yeah.
And we're here at NEAF in Suffern, New York, and looking forward to chatting with more people about Lowell's legacy over 125 years and all the neat things that are happening for our next 125.